Google runs average of more than 2 billion containers per week. That is, billion with B. If you're not aware of this fact, I know how surprising it will be. After hearing this for the first time, immediately there will be a couple of questions moving around in your mind. If I guess them correctly, you will be wondering how are these containers are created and managed at such a large scale? How do all these containers connect and communicate together? How do you scale these containers as per the traffic demand goes up and down, and so on? Hello and welcome to Container Orchestration Engine. In next few minutes, I'll try my best to get you up to speed on Container Orchestration Engine. But before you watch this video, it is required to have a basic understanding on containers and Docker. So, without any further delay, let's take a look at the things you'll be learning as part of this video. There are 4 primary things you'll be learning as part of this video. First, we'll discuss about a scenario where we don't require Container Orchestration Engine in first place. But in majority of scenarios, it is a must to have a Container Orchestration Engine. And we'll see that what are those scenarios are. Then, we'll discuss about what is Container Orchestration Engine. And finally, we'll discuss about the features of container orchestration. And with that, let's get started with our first thing in this topic, which is in what scenarios we don't require Container Orchestration Engine in first place. Let's imagine that you're working for a small startup where it has very few applications running. Let's say about 3 applications. In this scenario, you can manage and scale those applications manually as per the traffic demand with the help of some basic tools. So I guess I don't see any role of Container Orchestration Engine in that situation. But majority of companies are from mid-sized to large-scale enterprises, where they have hundreds of apps which is made up of thousands of microservices. So deploying and managing all these applications without some kind of an orchestration tool is almost impossible and chaos. So let's get more details around this topic in the next slide. So here's a problem that we're talking about in the previous slide. On one side, we have hundreds of apps which consists of large number of microservices. And on other side, we have a big IT infrastructure which consists of physical servers, in-house VMs, and cloud VM instances. Since we are talking about deploying and managing microservices, we need to talk about containers. Because majority of the time, these microservices will be running inside the containers, and most cases, these are Docker containers. And there are 2 problems associated if you're using Docker engine by itself without the help of Container Orchestration Engine. They are clustering and scalability. First, let's talk about the clustering. If you're using Docker engine by itself without Docker Swarm mode, then you are limited to managing these apps on single host. Since there is no clustering of servers, in case if the server fails, then app comes down. And that is one major problem. Now, moving on to the scalability. Let's imagine that your company has just released a product online. Fortunately, there is a great demand for that product more than initial expectations. But the unfortunate thing here is backend web application which is overwhelmed with the traffic from outside world. And it is on the verge of break. And now it's time to scale up and it will take time. And you're not sure will the application will be live till then. So scaling up and down with just a Docker engine is not easy. And we need a tool for that. And that tool is called as Container Orchestration Engine. So what is a Container Orchestration Engine? And we'll see that in next slide. So what is Container Orchestration Engine? Container Orchestration Engine is a tool to automate deploying, scaling, and managing containerized apps at a large scale in a dynamic environment. There are many container orchestration tools out there. Some of the popular well-known are Kubernetes, Docker Swarm, and Apache Mesos. DevOps team uses these tools to control and automate most of the tasks when it comes to managing the lifecycle of a container at a large scale from its creation to deletion. And we'll discuss more about on these topics in next few slides. So let's go back to the same diagram that we just saw earlier, where we have a bunch of apps and large IT infrastructure on other side. And this time, we also have a container orchestration engine in middle. There are two common primary things that any container orchestration engine performs. They are clustering and scalability. First, let's look at the clustering. The way clustering forms in most of the tools are, we have a master server where the orchestration engine is installed and configured. Then we join the worker nodes together along with the master node, thus form the cluster of nodes. Here, master server acts as a cluster manager which manages the worker nodes inside the cluster. So by performing the clustering, it opens to a lot of opportunities, primarily fault tolerance and scalability. Now we'll discuss about the fault tolerance and scalability in next slide. Next common feature is scheduling. As name indicates, we schedule something here, and that is containerized apps onto these worker nodes. Imagine that you are about to deploy an app, and the requirement here is to deploy apps onto a specific nodes which has SSD drives and for better I/O speed. And thanks to Container Orchestration Engine, with the help of that, you can deploy the apps onto the nodes where it has SSD drives. All we have to do here is define the requirement in a config file and submit it to the Container Orchestration Engine. Then it is a responsibility of Orchestration Engine to find the nodes which matches to the requirement and schedule the containerized app accordingly. That's about the scheduling. At a very high level, clustering and scheduling are two primary features of a Container Orchestration Engine. So what are the other important features of this tool? And we'll see that in next slide. In this slide, we'll see some other important features of Container Orchestration Engine. Before we discuss that, let's get a copy of picture we had in the previous slide. And here it is. We already discussed about the clustering and scheduling. Now, let's move on to the next important features of Container Orchestration Engine, which is scalability. And coming to the scalability, in general, the scalability means we are able to increase or decrease application instances or node instances as per the traffic demand. So, scalability is a way of increasing the number of application instances when the traffic demand from outside world goes up and down accordingly. The same applies to the size of the cluster, where we can scale up the cluster by adding additional worker nodes, and in the same way, we can scale down the cluster by removing the worker nodes from the cluster. So with the help of Container Orchestration Engine, we can scale up and down the application instances and the node instances dynamically as per the traffic demand. And that's about the scalability feature of Container Orchestration Engine tool. And next feature is load balancing. Imagine that you have multiple instances of your app running on multiple worker nodes. Then Container Orchestration Engine distributes the traffic equally across all application instances accordingly. It makes sure that no one specific worker node gets all the hit at the same time. So that's a responsibility of load balancer. And the next feature is fault tolerance. As we know, our containerized apps runs inside the containers, and these containers runs on top of worker nodes. So what if the container goes down or the worker node itself goes down? And this is where the fault tolerance features comes in. Typically, there will be a monitoring process running on the worker node all the time. And this monitors the containers and the worker node health status and submit it to the master node. If the container engine finds out the container is failed or stopped for any unknown reason, then it will recreate the containers on the same healthy node. In case the Container Orchestration Engine finds out the worker node inside the cluster is not responding, then it will reprovision containers from the failed node to a healthy node inside the cluster. So that's about the fault tolerance feature. And the last feature here is deployment. Container Orchestration Engine offers different ways to deploy apps Imagine that you have a version 1 of application A, and this is already deployed and running in production. And currently many users are using this application. So now you have to upgrade the version 1 to version 2 of application A. Since the application is already in use, now you need to figure out which type of deployment method need to use. Some of the scenarios are completely remove the V1 and deploy the V2. So there will be a downtime in between. And this method is called as recreate. In case if you don't want downtime, then you need to choose a different methodology, which can be a rolling update or canary method, where you will be slowly replacing V1 with V2. So with the help of Container Orchestration Engine, you have that flexibility to choose different methods of deployment. And that's about the deployments in short. So these are some of the important features of Container Orchestration Engine. So far in this video, we discussed about what is Container Orchestration Engine and its important features. And now the question is, what are the container orchestration engines that are currently available? And we'll discuss about that in next video. So before we move on to that, let's review some of the important points that we discussed in the last few minutes. Coming to the summary, first we discussed about the scenarios where we don't require container orchestration engine in first place. That is where company is very small, running very few apps. But not all companies are small. There are a majority of companies are from mid-size to large-scale enterprises. In that situations, deploying containerized apps is very challenging due to its size and the volume. And we discussed about the clustering and scalability are two major problems if the container orchestration engine is missing. Then we discussed about what is container orchestration engine. And it is a tool to automate deploying, scaling, and managing containerized apps at a large scale in a dynamic environment. There are many container orchestration tools, and some of the popular well-known are Kubernetes, Docker Swarm, and Apache Mesos. Finally, we discussed about the features of container orchestration engine. They are clustering, scalability, scheduling, load balancing, fault tolerance, and deployment. And these are some of the basic features of any container orchestration engine will offer. And coming up next, top 3 container orchestration engines. In that video, we'll discuss about what are the top 3 players in container orchestration engine space. And most of us know Kubernetes is one of them. But what are the other 2 top container orchestration engines besides Kubernetes? And we'll find that answer in that video. Finally, thank you so much for watching this, and I hope to see you in the next video. Most people are familiar with Kubernetes as one of the best container orchestration engine. But there are also other good container orchestration engines. And in this video, we will see what are the top 3 container orchestration engines and some of its trends. Hello and welcome to Top 3 Container Orchestration Engines. Before you watch this video, it is good to have a basic understanding of what is Container Orchestration Engine. So, without any further delay, let's take a look at the things you'll be learning in this video. There are 6 major things that we'll be learning as part of this video. First, I'll show you at a high level what are the top 3 container orchestration engines, and then we will discuss in depth about each of them. First, we'll discuss about the Marathon from Apache Mesos. After that, we'll discuss about the Docker Swarm from Docker Inc. Then, we'll briefly discuss about the Kubernetes. I made a dedicated video where I discussed in detail about Kubernetes in this series. Link to that video is provided in the description below. Then, we'll discuss about some of the cloud-specific container services. And finally, we'll discuss about the way to choose right container orchestration engines based on your team size and number of containers. So these are some of the objectives of this video. And now let's get started with our first thing in this video, and that is, what are the top 3 container orchestration engines? The top 3 container orchestration engines that we're going to discuss in this video are Marathon from Apache Mesos, Docker Swarm from Docker Inc., and finally, the gold standard of container orchestration engines, which is Kubernetes. First, let's get started with Marathon from Apache Mesos in next slide. If you take enterprise data center, where it consists of many physical servers and virtual machines. In most cases, we manage these servers individually or group of servers by VMware or other cluster manager. But how about managing all the servers inside the data center and treat that as one big supercomputer? That is where Apache Mesos comes in. So, Apache Mesos is an open source cluster manager which abstracts the CPU, memory, and storage and other compute resources away from these machines. These machines can be the physical machines or the virtual machines. Once all the nodes are connected and have the cluster in place, then we can submit the different types of jobs. And some of the job includes cron job, Hadoop, Spark, and Jenkins jobs are some of the examples of Apache Mesos jobs. And in the same way, there is a job for orchestrating containers. The job name is called as Marathon. So Apache Mesos Marathon is the first container orchestration engine out there. It came even before the Kubernetes, Docker Swarm, and others. So in Apache Mesos, for each job, there is something called framework. So there are total of about 20 plus frameworks, including the Marathon framework for container orchestration. And I need to clear something up here. And there is a big confusion out there. People are comparing Apache Mesos with Kubernetes. It's like comparing the oranges with lemons. Oranges has a kind of look like lemon, but not exactly the same. And in the same way, Apache Mesos Marathon is just one of the 20 plus frameworks that Apache Mesos supports. But people are taking out Marathon from its name and comparing just the Apache Mesos with other container orchestration engines such as Kubernetes. So in case if you come across any situation like this, then they just think that they meant Apache Mesos Marathon. The kind of a drawback for Apache Mesos is it is a bit complicated to set up than other container orchestration engine. So who uses the Apache Mesos Marathon? Typical users of Mesos are large enterprises that require lots of compute, job tasks-oriented workloads. Mesos is often used by companies that have to perform the big data jobs. Apache Mesos can be driven by developers rather than operations, but you require an operation team to manage the tool. So that's an high-level overview of Apache Mesos Marathon. And now let's take a look at another container orchestration engine. The next one is from Docker family, and that is Docker Swarm. Docker Swarm is another great product from Docker Inc. This product is focused on container orchestration. It is written in same programming language as the Docker Container Engine, which is Golang. It is a lightweight declarative language. Docker Swarm is easy to get started, set up, and understand. And it has the simplest architecture when compared to other container orchestration engines. If you're new to container orchestration, then it is a good idea to start with Docker Swarm. So who are the typical users of Docker Swarm? Mainly small to medium-sized teams like startups or medium-sized companies. And I've only seen the Docker Swarm using in brand new greenfield projects. It is extremely easy and takes just about 5 to 10 minutes to really set up this Swarm cluster. So one of the best things about the Docker Swarm is zero to dev experience is super easy. And this is mainly driven by the teams that are mostly developers who need to deploy new products. And the final gold standard of container orchestration is Kubernetes. This is like Linux OS in the enterprise operating system space. There are many different OSs, but Linux is a go-to operating system in most of the cases. And same applies for the Kubernetes in container orchestration space. There are two reasons for this. One, there is a strongest community behind the Kubernetes than any other open source project. Second, it is straight out of Google Inc. and now it is donated to and managed by Cloud Native Foundation, in short CNCF. And we'll discuss about the Kubernetes in another separate dedicated video after this. So that's about the Kubernetes at a very high level. Next, there are some cloud-based container services that we'll be seeing in next slide. As most of us are aware, there are primarily three cloud providers, which occupied more than 80% of the market share. As some of you guessed it right already. They are Google Cloud, Microsoft Azure, and Amazon Web Services. Each of these cloud providers offers the services to manage containers at a large scale. First, we have Google Kubernetes Engine. Since Google has been using containers since more than a decade, so they know better about how to manage containers at a large scale than anyone else. Kubernetes is from Google, so they leverage the same tool to manage containers on Google Cloud. Next, EC2 Container Services, and then Azure Container Services. Although they have their own way of managing containers, but they provide an option for using Kubernetes on their own platforms. So these are some of the cloud-specific container services. Now in the next slide, we'll see a graph to see which is the best container orchestration engine that best fits to your organization based on the size. Here is a simple chart with X and Y axis. On X axis, we have the size of the team from few to many, and Y axis, we have the range of hosts and containers from few to many. Let's assume that you have a large development team and they have a large number of hosts and containers. So in that scenario, the best tool for you is Kubernetes or Apache Mesos Marathon. As you can see, Kubernetes stands at the top when compared to the Apache Mesos Marathon. However, Marathon might be a good fit in case if you want to leverage some of the other frameworks that Apache Mesos offers along with Marathon. If you just want to use the container orchestration engine, then Kubernetes would be a go-to solution for you. I understand not all teams are big in size and has a large number of hosts and containers. In case if you fall in that mid-range, then Docker Swarm and Rancher will be a good fit. As we already discussed about the Docker Swarm, so moving on to the Rancher. Initially, Docker was designed to run container on a single host. So Rancher came into offering managing containers on multiple hosts. So that was about 1.0 of Rancher. Now Rancher 2.0 is kind of a support product for Kubernetes cluster management. Either you create a Kubernetes cluster within your private infrastructure or in the public cloud, Rancher offers to centrally manage all the Kubernetes cluster. Mainly it provides a clean user interface, user management, RBAC, logging, and monitoring are some of the features. So Rancher is now like a layer product on top of Kubernetes. Finally, we have Nomad. The primary difference between Nomad and other container orchestration engines are Nomad just offers the cluster management and scheduling and designed with Unix philosophy, whereas other container orchestration systems offer more than cluster management and scheduling, such as service discovery, monitoring, secrets management, and so on. So you should think twice when you're thinking about Nomad. So to recap everything here, Kubernetes and Marathon are good for larger organizations, and Docker and Rancher is good for medium scale, and Nomad is for someone who just want to manage clustering and scheduling. Overall, if anyone is thinking about container orchestration engine, then they should give a first thought about Kubernetes. Now, moving on to the summary. The first thing that we discussed in this video is what are the top 3 container orchestration engines. They are Apache Mesos Marathon, Docker Swarm, and Kubernetes. Then we discussed in detail about Apache Mesos Marathon. Apache Mesos contains about 20 plus frameworks, And one of the framework that supports the container orchestration is Marathon from Apache Mesos. Apache Mesos has a bit of complex setup than any other container orchestration engines. It is best suited for the mid to large scale companies who wants to use other frameworks besides using container orchestration framework called Marathon. Next thing that we discussed is Docker Swarm. Docker Swarm is a container orchestration engine product from Docker Inc. It is one of the simplest and easy to set up container orchestration engines out there. However, this is little less mature when compared to other container orchestration engine. It is ideal product for companies whose team size is small. After that, we discussed about the container orchestration engine, which is considered as gold standard of container orchestration engines, and that is Kubernetes. Kubernetes is a popular and most mature container orchestration engine out there. We discussed very briefly about that in this video because there is a separate dedicated video where I discussed why Kubernetes is best container orchestration engine out there. Then we discussed briefly about cloud-based container orchestration services. After that, I showed you how you can select best suitable container orchestration engine based on your size of your team. Where I mentioned Kubernetes and Marathon are good for larger organizations and teams, and Docker and Rancher is good fit for medium scale companies and teams, and Nomad is for someone who just want to manage clustering and scheduling functionality. So overall, if anyone is thinking about container orchestration engine, then they should give a first thought about Kubernetes. And now, this topic leads to our next topic, and which is what is and why Kubernetes. In that video, I discussed about what is Kubernetes and why it is one of the most popular container engines out there. And finally, thank you so much for watching this and hope to see you in the next video. So you heard about Kubernetes, but not quietly got what it is and why it is one of the best container orchestration engine. So let's try to find out answers to those questions in this video. Hello and welcome to Kubernetes overview. So in next few minutes, I'll try my best to explain what is Kubernetes and why it is one of the best container orchestration engine. So before you watch this video, it is required to have a basic understanding on containers, Docker, and container orchestration engine. So without any further delay, let's take a look at the things you will be learning in this video. This presentation is divided into two parts. The first part focuses on what is Kubernetes. Then we'll look into where it is born and who developed it. After that, we'll discuss about what are its goals and who is managing it currently. So all this goes into the part 1. Next, coming to the part 2, where we discuss about why Kubernetes is one of the best container orchestration engine. There we'll discuss about the largest deployment of Kubernetes so far. Then we'll look at the various stats to show why Kubernetes is the leading container orchestration engine out there. So with that, let's get started with our first part 1, and that is, so what is Kubernetes? Kubernetes is an open source container orchestration engine to manage containers at a large scale. Kubernetes will provide all the features needed to run Docker or Rocket-based container applications, including cluster management, scheduling, service discovery, monitoring, secrets management, and more. So Kubernetes is born and designed at Google. And later on, Google donated Kubernetes to Cloud Native Foundation, in short, CNCF. Since then, Kubernetes is governed by CNCF and maintained by CNCF. So CNCF is an independent organization, and it gained a lot of support from major players in the industry, such as Google, Red Hat, CoreOS, Microsoft, Amazon, Docker, and many other important players in the industry. Let's quickly go through some of the history behind Kubernetes at Google. In this slide, let's find out how Google manages its 2 billion containers every week. Containers are new to this world, but not for Google. They have been using these containers since more than a decade. It runs about 2 billion containers every week. As it might be surprising, Google runs its core products such as Gmail, YouTube, and Google Search inside containers. As some of you are aware, Kubernetes was released in 2014. So how is Google managing all these containers since more than a decade ago? That's with their secret proprietary tool, and that tool is called as Borg. Outside world got to know about Borg only after it released Kubernetes. So they have been using this Borg to create the cluster of servers, then deploy containerized apps and scale it as per the demand. So when Google saw the emerging container technology after Docker released its first version of Docker Container Engine back in 2014. So during that time, internally at Google, a couple of engineers along with Joe Bida, Brendan Burks, and Craig thought of coming up with a new tool from their lessons learned from the Borg and their more than decade of experience in the container space. And that tool now is called as Kubernetes. So Borg and Kubernetes might be similar in terms of features, but Kubernetes was designed and developed from ground up, just like any other brand new tool. The code of Borg and Kubernetes is completely different. We can think Kubernetes is a slimmed down version of Borg. So currently, Kubernetes is a default container orchestration engine on Google Cloud. So that's a bit about the history of Kubernetes. So Google announced Kubernetes to the outside world by end of mid-2014. But the actual Kubernetes v1 was released around mid-2015. So around same time, Google donated Kubernetes to CNCF. So the people who are not familiar with Cloud Native Computing Foundation, in short, CNCF, it is a vendor-neutral home for many of the fastest growing projects on GitHub, including Kubernetes, Prometheus, and Envoy. CNCF offers the official certification in Kubernetes. So, since then, Kubernetes was governed by CNCF and it gained a support from major players in the industry. As of this recording, latest stable release of Kubernetes is 1.11.3, and this version is released on September 9th, 2018. So when they initially released Kubernetes, they had few goals and considerations in mind. Let's see what they are. First, its goal is to empower application developers with a powerful tool like Kubernetes, so that they don't have to interact with underlying infrastructure. Also, that reduces their dependency on operations team. Next, to provide standard deployment interfaces and primitives for a consistent app deployment. And the last one is, it is built with modular API. So what that means is, it allows third-party vendors to integrate their systems around Kubernetes technology and provide some of the commercial solutions to the operational challenges that we face day to day on running Kubernetes deployment on our own. Rancher is one of the company which took the advantages of this and started offering services on top of Kubernetes, like deploying applications on Kubernetes and managing your Kubernetes cluster. That's all possible because of Kubernetes Modular API. Sometimes Kubernetes is also called as K8s in short. This naming convention traces back to early 80s, where software development was still in initial days. So in 80s, there used to be a long word such as internationalization and localization. So to overcome those long words, developer prefers to use the shortcuts. So how these shortcuts are formed? This is by taking the first letter and the last letter and number of characters in between. So if you take the Kubernetes, here the first letter is K and number of letters between the first and last letter is 8 and the last letter is S. So that's how you get the K8s. And finally, Kubernetes was developed using Go language. In short, Golang. So that's about the Kubernetes. So this concludes our part 1. Next, we'll discuss why Kubernetes is the leading container orchestration technology in part 2. The first reason why you should consider Kubernetes even in the first place is it is from Google. Google created this tool based on their years of learning experience with the deploying and managing containerized apps at a very large scale. So if you look at the kind of features and sophistication that Kubernetes has, it clearly has that Google footprint on that. Google donated Kubernetes to CNCF Foundation, and Kubernetes is now open source. Anyone can download the code of Kubernetes and make changes to it and use it. And Kubernetes has one of the largest open source community than any other open source tool. And that is one of the important advantages of using Kubernetes. Next, maturity. Second important thing about Kubernetes is its maturity. You see a lot of organizations who have moved to Kubernetes, and you see companies like Walmart and Apple are already using Kubernetes. There are clusters with more than 2000 nodes. It comes with all that reliability you need. So it has been there in production for almost 3 to 4 years now. So that's how mature Kubernetes is. Next, its features. Actually, a lot of features that amount to the features of Kubernetes is overwhelming. By the time you get to understand and get your hands dirty about a specific feature, then there is a new feature of Kubernetes will show up. I guess Kubernetes is one of the most feature-rich container orchestration tool than any other tools available in that category. Next, it is easy to integrate. Kubernetes has a modular API which allows you to integrate with any other third-party tools without any much effort. In fact, there are companies who have built solutions on top of Kubernetes, such as Red Hat OpenShift, Rancher. Besides that, Kubernetes is not just limited to run Docker-based containers. You can use Rocket-based containers as well. Rocket is another container engine created by CoreOS, which has recently been acquired by Red Hat. Rocket is an interesting product as well as interesting alternative to the Docker. So Kubernetes works with all these container runtime engines and open to integrate with third-party monitoring and logging tools. And finally, Kubernetes is an open source product which is mainly driven by its huge community around it. It is one of the largest open source projects on GitHub, and it is driven by nearly 2000 contributors, and it has around 70,000 commits. So these are some of the main reasons why Kubernetes is ahead of all other tools in this game. Also, there are a few more reasons coming up in next slide on why you should consider Kubernetes as your container orchestration engine. And we'll see that in next few slides. I guess most of you heard about Pokemon Go. So when they released this game around mid-2016, they initially expected network traffic, let's say X. But when the game was released, within minutes, traffic surged more than 50 times than initial expectation. And that comes to 50x. Eventually, this unexpected traffic crashed the Pokemon Go servers. So at that time, to keep up with traffic, Niantic, the company behind Pokemon Go, took the help of teams at Google to move Pokemon Go onto the Google Container Engine. So till date, Pokemon Go is the largest Kubernetes deployment on Google Container Engine. If you look at the Kubernetes meetups worldwide, there are more than 150,000 members in various meetup groups in 60 countries. These are certainly a very huge numbers for a 3-year-old technology. And now, let's take a look at Kubernetes on GitHub and then compare with another popular open source project, which is Docker. Here are the screenshots from Docker and Kubernetes from GitHub. If you compare these numbers, you can easily understand why Kubernetes is more popular open source project than Docker. As you can see, Kubernetes is started 40,000 times and forked more than 2,500 times and has almost 70,000 commits so far. So just to avoid misunderstanding here, Kubernetes and Docker are not competitors. Kubernetes uses Docker as container runtime engine. I'm comparing here because Docker is one of the most popular open source project out there. The key takeaway point from here is Kubernetes open source project is more popular than likes of Docker. Now, in the next slide, let's take a look at the graph of Slack users and job postings related to Kubernetes from its initial release. So here is a graph of Slack users. So to someone who are not familiar with Slack, it is just a group chat where users across the globe come together and collaborate on things they are doing. As you can see, they had about few hundreds of users at the beginning of Kubernetes release. And now it reached to more than 30,000. As of this recording, there are about 46,000 plus Slack users in Kubernetes group. Anyone can join. You can also join this Slack group and ask questions if you are having any issues with Kubernetes or need any help with Kubernetes. So that's about the Slack users in Kubernetes. And now let's take a look at the job postings related to Kubernetes. As you can see, that's a sharp line projecting to upward direction. So I guess people with Kubernetes knowledge and experience has a bright future ahead. And these are some of the companies running Kubernetes inside their environment. As you can see, there are some of the well-known companies in this list, such as Walmart, Viacom, Goldman Sachs, Pearson, New York Times, Apple, and more. I guess by now you should think about why Kubernetes is a leading container orchestration engine out there. And by the way, this video is just a starting point to the Kubernetes course. So before I end this, let me give you a summary of what I've been talking over the last few minutes. So coming to the summary, in part 1, first we discussed about what is Kubernetes. Kubernetes is an open source container orchestration engine and it manages containerized applications at a large scale. And it provides all the features needed to run Docker or Rocket-based containers, including cluster management, scheduling, service discovery, monitoring, secrets management, and more. And then we discussed how Google has been using containers since more than a decade. There, we discussed about Borg and mentioned Kubernetes was a slimmed down version of Borg. However, Kubernetes was developed from ground up. Also, we discussed Kubernetes was released around 2015 and later on, Google donated Kubernetes to an independent organization called CNCF. Since then, Kubernetes was governed by CNCF. Also, we discussed about the goals of Kubernetes and how it got its name as K8. In part 2, we discussed why Kubernetes is a leading container orchestration engine out there. To support that statement, we discussed about few statistics from GitHub, Slack, search trend, job postings, and companies using Kubernetes. And now, this video leads to our next topic, which is Kubernetes architecture. In that video, we'll discuss what goes inside the Kubernetes architecture, what are the components it consists of, and some of the basic terminology of Kubernetes. And finally, thank you so much for watching this, and I hope to see you in the next video. Learning any tool or technology starts with knowing its architecture and its terminology. These architectures can sometimes be complex. Kubernetes architecture is one of them. So goal of this video is to make your learning experience of Kubernetes as easy as possible. Hello and welcome to Kubernetes architecture. In next few minutes, I'll try my best to explain what are the nuts and bolts that goes inside Kubernetes architecture and go through some of the important basic terminology of Kubernetes. Before you watch this video, it is required to have a basic understanding of what is Kubernetes. So, without any further delay, let's take a look at the things you'll be learning in this video. There are 5 primary things you'll be learning as part of this. First, I'll show you the Kubernetes architecture overview at a very high level. So once you get comfortable with it, we will next look at the Kubernetes master component. Then after, we will look at the Kubernetes worker node. After that, we will combine this master node and the worker nodes together to form the complete Kubernetes architecture. Then you will get a clear picture of Kubernetes architecture. Finally, we will review the terminology we used as part of this discussion. So, these are the primary objectives of this video. And now, let's get started with first thing in this video, and that is Kubernetes at a very high level. Let's imagine a typical team structure where there will be one or more team members. So to provide a direction and manage to this team, we have a manager. All of the team members works together on the common goal, and the team manager is the one who coordinates various activities and supervises the entire team. And Kubernetes architecture works in the similar way. Like any other distributed application, Kubernetes architecture consists of at least one master node and multiple worker compute nodes. For simplicity purpose, we have a one master and three worker nodes here. But in reality, there will be more than one master server for high availability and fault tolerance purpose. And worker nodes can go up to hundreds or even thousands as well. Currently, Kubernetes supports up to 5,000 worker nodes per cluster. So let's discuss some of the very basic and most common components of Kubernetes cluster here. First, let's start with Kubernetes worker node. The worker nodes are nothing but a virtual machines or a physical servers running within your data center, or it could be a VM in cloud. These are the workhorses of a Kubernetes cluster. They expose the underlying compute, networking, and storage resources to the applications. So all these nodes join together to form a cluster with providers, fault tolerance, and replication. By the way, don't get confused if someone calls these nodes as minions, because in the early days of Kubernetes, it is called as minions. I guess we hardly see anyone calling with that name now. But for the rest of the course, we'll stick with calling it as worker node or just a node. Next, now moving on to the pods. I guess this is one of the most used terms in Kubernetes. So what is a pod? This is basically a scheduling unit in Kubernetes. So to help you better understand, you can think pod as VM in virtualization world. In Kubernetes world, we have a pod. Each pod consists of one or more containers. In most cases, there will be one container. There are scenarios where you need to run two or more dependent containers together within a pod, where one container will be helping to another container. So with the help of pods, we can deploy multiple dependent containers together. So this pod acts as a wrapper around these containers. We interact and manage containers through pod. Next, moving on to containers. I guess most of you are already familiar with containers by now. In case if you have jumped directly right here, don't worry. Containers are a runtime environment for containerized applications. You run container applications inside the containers. These containers resides inside the pod. Also remember that containers are designed to run microservices. Containers are not ideal for running monolithic applications. And finally, the master. Master is responsible for managing whole cluster. It monitors the health check of these nodes. It stores the information about the members of the cluster and its configuration inside the master. So when worker node fails, it moves the workload from failed node to another healthy worker node. Kubernetes master is responsible for scheduling, provisioning, controlling, and exposing API to the clients. So that's about the Kubernetes master at a high level. So this is a very basic architecture of Kubernetes, where you have a master and worker nodes, pods, and containers. One thing to remember to avoid the confusion here is, so you have a worker node. Inside the worker nodes, you have a pods. Inside these pods, you have containers. If you remember that relationship, that will be easy. And also one more thing, inside these pods, you can have one or more containers. So that's about the basic architecture of Kubernetes. And now it's time to go a little bit in depth. First, let's look at the Kubernetes master, and we'll see what are the 4 components that makes up the Kubernetes master and how we interact with Kubernetes master. So coming to the Kubernetes master is responsible for managing the entire cluster. It coordinates all the activities inside the cluster and communicates with the worker nodes to keep Kubernetes and your applications running. So when you install Kubernetes on your system, there are 4 primary components of Kubernetes master will get installed. First, the API server. API server is kind of a gatekeeper for entire cluster. If you want to create, delete, update, or even display any Kubernetes object, it has to go through that API. API server validates and configures the API objects such as pods, services, replication controllers, and deployments. And it is responsible for exposing various APIs. It exposes APIs for almost every operation. So how do we interact with this API? Using a tool called kubectl. It is also called with various names such as kubecontrol and also kubectl. It is a very tiny Go language binary. It basically talks to the API server to perform any operations that we issue from the command line. So that's about the API server. Next comes the scheduler. As you may guess, scheduler is responsible for physically scheduling pods across multiple nodes. So depending upon the constraints that you mentioned in configuration file, scheduler schedules these pods accordingly. For example, if you mention CPU has 1 core, memory is 10 gig, the disk type is SSD, and other affinity or other constraints that you may want to declare in the artifact. So once we pass this artifact to the API server, the scheduler will look for the appropriate nodes that meets this criteria and will schedule the pods accordingly. So that's about the scheduler. Now moving on to the next component, which is control manager. Actually, there are 4 controllers behind the control manager. They are node controller, replication controller, endpoint controller, and service account and token controllers. So at a high level, these controllers are responsible for overall health of entire cluster. It ensures that nodes are up and running all the times and correct number of pods are running as mentioned in the spec file. So that's about the control manager. Finally, etcd. At the bottom, you're seeing what is called as etcd. etcd is a distributed key value lightweight database. It is developed by CoreOS. It is a very popular distributed key value database. So etcd in Kubernetes is going to be the central database to store current cluster state at any point of time. Any component of Kubernetes can query etcd to understand the state of the cluster. So this is going to be the single source of truth for all the nodes, all the components, and the masters and that are forming Kubernetes cluster. So these are the 4 important components of Kubernetes master, which includes API server, scheduler, controller, and etcd. So coming to the Kubernetes worker node, as we discussed earlier, worker node can be any virtual machine or a physical server where containers are deployed. Every node in the Kubernetes cluster must run a container runtime such as Docker or Rocket. There are 2 other Kubernetes components also required for us to communicate with Kubernetes master, and they are kubelet and kubeproxy. So what are these kubelets and kubeproxy? First, let's take a look at the kubelet. The kubelet is a primary node agent that runs on each worker node inside the cluster. So the primary objective of this kubelet is, it looks at the pod spec that was submitted to the API server on the Kubernetes master and ensures that containers described in that pod spec are running and healthy. In case if the kubelet notices any issues with the pods running on the worker nodes, then it tries to restart the pod on the same node. So in case if the issue is with the worker node itself, then in that case, Kubernetes master detects a node failure, then it tries to decides to recreate the pod on another healthy node. So it all depends on if the pod is controlled by a ReplicaSet or a replication controller. If none of them are behind this pod, then pod dies and will not be recreated on anywhere. So it is advised to use pod with a deployment or a ReplicaSet. Don't worry if you're not aware of all the deployment and ReplicaSet terminology. They are detailedly explained in the following videos. And next comes the kubeproxy. Kubeproxy is a critical element inside the Kubernetes cluster. It is responsible for maintaining the entire network configuration. It essentially maintains the distributed network across all the nodes, across all the pods, and across all containers. And it also exposes services to the outside world. It essentially the core networking component inside the Kubernetes. So that's about the kubelet and kubeproxy. And now coming on to the pods and containers. So we have briefly discussed about pods and containers earlier in this video. But again, let's discuss it one more time. So pod is basically a scheduling unit in Kubernetes, just like VM in the VMware world. So each pod consists of one or more containers. In most cases, there will be one container. There are scenarios where you need to run two or more containers together inside a pod. In that case, one container can be helping the other container. So the primary advantage of pod is we can deploy multiple dependent containers together. So it acts as a wrapper around these containers. And we interact and manage these containers primarily through pod. So that's about the pods. Now we move on to the containers. I guess most of you are already familiar with it by now. It provides a runtime environment for applications. You can run containerized application processes inside these containers. As we discussed just a few minutes back, these containers reside inside the pod. Also remember that containers are designed to run microservices, which is not ideal for monolithic applications. So most importantly, Kubernetes supports Docker-based containers as well as Rocket-based containers. You might come across Docker-based containers quite often than others. So the four primary components inside the worker nodes are kubelet, kubeproxy, pod, and container. Besides that, there will be other add-ons such as C advisors and other plugins depending upon the requirement you have. So that's about the Kubernetes worker node and its components. So far we have seen the Kubernetes master and the Kubernetes worker node in two separate sections. And now let's combine these two. If you combine these two, this is what you get. The complete Kubernetes architecture cluster. As you can see, on the master node we have API server, scheduler, controller, and etcd. And on the client node, we have kubelet, kubeproxy, pods, and containers. In most cases, master node does not contain any containers. It just manages the workload on the worker nodes. And also, it makes sure the cluster of worker nodes are running healthy and successfully. In the above diagram, you are seeing only one worker node. But Kubernetes supports up to 5,000 worker nodes inside one cluster. So as you go deep into Kubernetes, these components will be part of our discussion very often. So for that reason, let's review all these components for one last time. Let's first review the components of Kubernetes master. They are API server, scheduler, control manager, and etcd. First, API server. So it's kind of a gatekeeper for entire cluster. In case if you want to create, update, delete, or even display any Kubernetes objects inside a Kubernetes cluster, it has to go through the API server. API server validates and configures the API objects that we submit. These API objects can be pods, services, replication controllers, deployments, or some more. So we interact primarily with API server using kubectl command. So that's about the API server. And next comes the scheduler. So scheduler is responsible for physically scheduling pods across multiple nodes. So depending upon the requirement that we submit to the API server, this scheduler will schedule pods accordingly. Next comes the control manager. Control manager is responsible for overall health of the entire cluster. It ensures that nodes inside the cluster are up and running and correct number of pods are running as mentioned in the spec file. And finally, we have etcd in master section. etcd is a central database to store current state of the cluster at any point of time. Your cluster information, nodes, secrets, controllers, and other objects configuration is stored inside the etcd database. Any component of Kubernetes can query the etcd to understand the state of the cluster. So this is going to be the single source of truth for all the components and the nodes inside the Kubernetes cluster. So these are 4 important components of Kubernetes master, which includes API server, scheduler, controller, and etcd. And now moving on to the worker node section. So coming to worker node section, we have a kubelet, kubeproxy, pods, and containers. First, kubelet. Kubelet looks at the pod spec that was submitted to the API server and ensures that containers described in that pod spec are running successfully and healthy. In case if kubelet notices any issues with those pods, then it tries to restart those pods on the same node. In case if the issue is with node, master detects a node failure and launches the pods onto another healthy node. Next comes the kubeproxy. Kubeproxy is responsible for maintaining the entire network configuration. It essentially maintains the distributed network across all the nodes, pods, and containers. And it also exposes services. Kubeproxy is essentially the core networking component of Kubernetes. After that, we have pods. Pod is basically a scheduling unit of Kubernetes. Each pod consists of one or more containers. In most cases, there will be one container. There are scenarios where you need to run 2 or more dependent containers together within a pod, where one container will be helping another container. So with the help of pods, we can deploy multiple dependent containers together. In Kubernetes, we primarily interact with pod than containers. Each pod has unique IP address inside the Kubernetes cluster. And finally, containers. Containers provide the runtime environment for applications. Containers will reside inside a pod. Containers consist of applications, libraries, and their dependencies. So that's about the Kubernetes worker node section. So these are some of the core important terminology that you want to remember. So that's about the Kubernetes architecture and its terminology. So before we move on to the next video, let's review the summary of what we have been discussing for over the last few minutes. So coming to the summary, first we looked at the very high-level overview of Kubernetes architecture, where we discussed high-level overview of architecture with some core components such as Kubernetes master, Kubernetes worker node, pods, and containers. Once we are comfortable with that, then we looked at the Kubernetes master node section in detail. In that, we discussed about 4 important components of Kubernetes master, which are API server, scheduler, controller, and etcd. After that, we discussed about the node section. In that, we discussed about 4 important core components of worker node, which are kubelet, kubeproxy, pod, and containers. After that, we combined these both master section and the worker node section to form the complete Kubernetes cluster. And finally, we reviewed the key terms we used in the master section and the worker node section. And now, this video leads to our next topic, which is installation methods of Kubernetes. In that video, we'll discuss what are the different ways you can install the Kubernetes. Then after, we have a demo for each of these. And finally, thank you so much for watching this and I hope to see you in the next video. You can install and configure Kubernetes in different ways. You have an option to configure Kubernetes cluster within seconds, in minutes, and even hours. Most importantly, you have different options available to install Kubernetes on your personal laptop, physical server, virtual machines, and as a cloud service. Hello and welcome to installation methods of Kubernetes. Before you watch this video, it is required to have a basic understanding of what is Kubernetes and its Kubernetes architecture and containers. So, without any further delay, let's take a look at the things you will be learning as part of this video. In this video, we'll primarily discuss about a high-level overview of various ways we can install Kubernetes. This is just a very short video. It has barely one slide, but this gives you a very good clear idea about what are the different ways we can install Kubernetes. So let's get started. First, let's start with Play with K8s. In case if you're familiar with Play with Docker website, then Play with K8s is designed in a similar way. This is ideal for someone who does not want to install anything on their system or laptop, but want to do a quick testing or a learn about Kubernetes. And this is a ready-made Kubernetes cluster available online. All you have to do is just visit the website https://labs.playwithk8s.com or just simply Google it to try this out. And we have a dedicated demo on this following current video. Next comes the Minikube. Minikube is ideal for someone who want to install Kubernetes on their system but has a very limited system resources. So the key takeaway point with Minikube is you do not have a separate Kubernetes master and a Kubernetes node worker node architecture. You get all Kubernetes components packaged into one. It is all-in-one setup. Same system acts as a Kubernetes master and same system acts as a Kubernetes worker node. And we have a dedicated demo on this as well. Next, moving on to Kubeadm. Kubeadm is a way to go if you want to get actual real-time setup. We can do that using Kubeadm tool. Using that, you can set up multi-node Kubernetes cluster. And this is one of the popular installation methods of Kubernetes. So depending upon the system resources you have, you can create multiple VMs. Then you can configure Kubernetes master and node components. In case you have a limited system resources but want to use Kubeadm method, then you might want to spin up cloud-based VMs. This is exactly what we are going to do in this course. We have dedicated video on this. So that's about the Kubeadm. Besides these three, there are other three popular cloud-based platforms which offer Kubernetes service on their platform. They are Google Kubernetes Engine, Amazon Elastic Container Services for Kubernetes, and Azure Kubernetes Service. So what's common and cool with these cloud-based Kubernetes services are, all you need to define is how many nodes in your cluster should be and the size of CPU and RAM each node should contain. So once you fill all these details and submit, then these cloud services will automatically set up Kubernetes configuration and takes care of a whole lot of things. And we have a dedicated video on Google Kubernetes Engine to discuss this in detail. So that's about the high-level overview. So without much delay, let's start with our next topic, and that is Play with K8s. As we discussed, Play with K8s is one of the easiest way to install and use Kubernetes. And in that video, we'll discuss what is Play with K8s, how to create Kubernetes cluster on Play with K8s, and test the deployment to make sure our configuration is working as expected. And finally, thank you so much for watching this, and I hope to see you in the next video. Imagine that you want to quickly test something on your Kubernetes cluster. Unfortunately, it is not readily available. At the same time, you don't want to go through all the complex setup of Kubernetes cluster. So, what is your option now? Hello and welcome to Play with K8s. So before you watch this video, it is required to have a basic understanding of what is Kubernetes and containers. So without any further delay, let's take a look at the things you will be learning as part of this video. First part focuses on discussing what is play with K8s and what it does. In second part, we focus on reviewing demo we actually about to do on live. In this, I'll show you how you can create Kubernetes cluster, configure Kubernetes master, and then configure Kubernetes worker node, and finally deploy and test application on play with K8s. In part 1, we'll discuss about what is play with K8s and what it does. So play with K8s website provides a Kubernetes playground. This is similar to play with Docker, and this will give you a configured environment to start playing and exploring Kubernetes API. And this will allow you to use and learn Kubernetes entirely within from your own browser. So this is without installing anything. And this is provided by Docker and created by tutorials. This website came to live around mid-2017. And this is still in initial stage when compared to play with Docker website. But yes, there is a large community around this website who are actively working on its improvements. In case if you want to use this website, you are required to have either GitHub or Docker account. So once you log into this website, you will see how easy it is to create Kubernetes cluster. It actually takes about not more than 60 seconds to configure the Kubernetes master node and add 2 Kubernetes worker node to the Kubernetes master. However, you can't just create the cluster and forget about it. There is a clock ticking. You have a 4 hours time limit once you start the session. So watch out for it. Again, 4 hours is pretty good amount of time if you want to just try out something out quickly. So that's a high level overview of Play with K8s website. And these playgrounds are great for experimenting and trying out something very simple. So that's all about with Play with K8s at a high level. In short, this is Kubernetes on a website with no strings attached. Now moving on to the part 2. Now in this part 2, we will create Kubernetes cluster by adding nodes on Play with K8s website. Then we will configure one of the node as Kubernetes master. After that, we will configure the remaining nodes as the Kubernetes worker nodes and then join them to the Kubernetes master, and thus forms the cluster. Finally, we will deploy the sample application to make sure if everything working as expected. Now, let's take a look at the UI of Play with K8s website. So once you log into that website, here is the screen you will get once you log into that site. As I mentioned earlier, there is a 4-hour time limit for every session. You can see the timer on the upper left-hand side of the screen. Just below the timer, there is an option to add new instances. You can add up to maximum of 5 instances. In that case, one instance will be master and other 4 instances can be Kubernetes worker nodes. Moving on to the right-hand side of the screen, on upper top corner, you can see the IP address of the instances, memory, CPU, and external IP address. Underneath that, you have an option to delete this instance. Finally, we have the screen with shell prompt, where you can execute all the commands from it. Now, let's see the steps involved in creating Kubernetes master node, and then we'll look at the Kubernetes worker node. This will be extremely simple. First, let's take a look at the master node configuration. So before we configure the master node, first we will add the new instances. Once it is done, we'll configure the node as a master node using Kubeadm init command. This Kubeadm init command will be provided at the start of your session. You can just copy and paste that init command to initialize any node as master. So after you initialize the node, the output will print the join command on the screen. So you need this join command to configure the worker nodes. I advise you to copy and securely save it at some place that you can refer it later on. So once you're done with initializing master node, then you will be configured the network plugin. This network plugin will help us establish communication between all the pods on all nodes inside the cluster. And there are various plugins such as Flannel, Calico, and Wave. So to install this network plugin, we will just copy and paste the command that was given to us at the beginning of the screen. That command will install the Wave network for us. So once you're done with initializing the master node and configuring network, your master node is now ready. And now it's time to join the worker nodes to the cluster. You can join the worker node to the cluster using Kubeadm join command that you are seeing on the screen. Now let's see the steps involved in creating worker node. First thing to do here is to create the new instances. If you have new instances already created and ready, all you need to do is execute one simple join command that you see on the master node. Execute the same Kubeadm join command on the worker node and you are all done. This join command will add this worker node to the cluster. And you can follow the same steps to add more instances to the cluster. Again, maximum number of instances that you can add or create in PlayWithK8's website is 8. So far we have configured one master node and one worker node. For now, let's go ahead and deploy sample application to make sure everything is working correctly as we are expecting. Currently we are on node 1, which is master node. First, let's go ahead and display the nodes within the cluster. As you can see, there are two nodes, node 1 and node 2. Here, node 1 is a master node and the node 2 is a worker node. They are both in ready status. So we are fine with that. As we have a nodes ready, then let's go ahead and deploy simple application. And you can do that using kubectl run command. Don't worry if you're not aware of that, what this kubectl run command is. We have dedicated videos on that. Just follow this course track. So once you execute this command, you can see the deployment created successfully. And let's do a final testing by displaying the pods that are created as part of above deployment. So for that, you need to execute kubectl get command to display it. As you see, there is one pod which is in running state. That's exactly what we are expecting. From above all three test results, nodes inside the clusters are ready, and then we successfully deployed sample application. And finally, we verify the pods are in running status. Everything looks great. Now, let's move on to the final part. In part 1, we discussed about what is PlayWithK8 and why we use it. PlayWithK8 is similar to PlayWithDocker, but not as mature as that. PlayWithK8 is still just a more than a year-old product. On PlayWithK8's website, you can create the cluster, deploy the applications, and test it. However, there is a time limit of 4 hours. So this is basically used for learning and quick testing purpose. No software applications are required to install on your laptop to use this. So to access the PlayWithK8, just type the labs.playwithk8.com on your web browser or just simply Google it. And in part 2, we reviewed the demo we are about to perform on live PlayWithK8's website. First, we created the nodes which are part of the Kubernetes cluster. Then, we configured one of the node as a Kubernetes master. After that, we configured one more node as worker node and joined this worker node to the master. And finally, we deployed a sample application and tested to make sure if everything is working as expected. And that's all about with PlayWithK8 in this demo. And now coming up, actual demo of PlayWithK8, where we will perform the exact steps that we just discussed in the review demo section. And finally, thank you so much for watching this and hope to see you in the next video. Imagine that your management asked you to set up 3-node development cluster within your company's infrastructure. In this scenario, how do you install and configure Kubernetes cluster? Hello and welcome to Kubeadm. So in next few minutes, I'll try my best to get you up to speed on what is Kubeadm and how to install and configure Kubernetes cluster using Kubeadm. But before you watch this video, it is required to have a basic understanding of what is Kubernetes and its basic architecture. So without any further delay, let's take a look at the things you'll be learning in this video. This presentation is divided into two sections. In first section, we'll discuss the concept around Kubeadm. First, what is Kubeadm and what it does. Then, we'll discuss about the commands related to Kubeadm. So that's about the section 1. After that, we will review the demo we are able to perform on live system. This will help you better understand when you watch actually doing it live. In this review demo, I'll show you what are the prerequisites required before you install Kubernetes. Then we'll install the software applications related to Kubernetes. After that, we will configure the Kubernetes master node. Then we will configure the Kubernetes worker nodes and join the worker nodes to the cluster. And finally, we'll test and validate entire setup. So that's about the section 2. In case if you are looking for a live demo on installing Kubernetes on Kubeadm on the system, then please do check the links in the description below. And now, let's get started with what is Kubeadm and what it does. First, let's discuss about what is Kubeadm. Kubeadm is a command line utility which will help you to bootstrap your Kubernetes cluster that conforms to the best practices. So before Kubeadm, things were very complex and time-consuming to configure Kubernetes cluster. So if you are just curious how hard it is, then just Google Kubernetes the hard way. The results will show you the Kesley Hightower's how to guide in configuring Kubernetes hard way. But luckily, with the help of Kubeadm, all that complexity was hidden and made it a lot easier for newcomers to configure Kubernetes cluster. If you are new to Kubernetes, then you can start with Kubeadm to try Kubernetes, and which will make your life much better. If you are someone who are already familiar with Kubernetes, then you can spin up the cluster with Kubeadm and test their applications. So now, let's see what are some of the operations that you can perform with Kubeadm in next slide. In this slide, we'll go through some of the Kubeadm commands. First command is Kubeadm init. Kubeadm init will initialize the Kubernetes master node. So run this command whenever you want to configure any node as master node. After Kubeadm init, next thing we are going to look at is Kubeadm join command. So Kubeadm join will initialize the worker node. So run this command whenever you want to configure any node as worker node inside the cluster. Let's review it again. We have a Kubeadm init to initialize the master node, and we have a Kubeadm join command to initialize the worker node. So these are the two most frequently used commands when it comes to the Kubeadm. So there are few other commands that you might want to be familiar with. At a high level, Kubeadm token command. This command will help you create tokens. Next comes the Kubeadm version. As its name implies, Kubeadm version prints the version of Kubeadm. And final command here in this list is Kubeadm upgrade. Kubeadm upgrade is a user-friendly command that wraps complex upgrading logic behind one command. So with the help of Kubeadm upgrade, we can upgrade the Kubernetes and also we can downgrade the cluster if necessary. So these are some of the commands related to Kubeadm, and there are some more available on the website. Overall, Kubeadm init and Kubeadm join are the two commands that you might want to focus extra on this one. Overall, you might want to more focus on Kubeadm join and Kubeadm init in this video. So with that, let's move on to the next slide. Before we get into the details, I just want to quickly show you how Kubernetes architecture will look like and what are the components Kubernetes master and the worker node has. As you can see, Kubernetes master consists of API server, scheduler, etcd, and control manager. Here, API server is kind of a gatekeeper for the entire cluster. If you want to create, update, delete, or even display any Kubernetes object, it has to go through API server. Next, scheduler. It is responsible for physically scheduling pods across the nodes inside the cluster. Next, controller. Controller is responsible for overall health of entire cluster. It ensures nodes are up and running and correct number of pods are running as mentioned in the spec file. And finally, etcd. etcd is going to be the Kubernetes central database to store entire Kubernetes configuration, including objects it is creating, secrets, and more. It is a key value database. Any component of Kubernetes can query etcd to understand the state of the cluster in real time. And now, moving on to the node components. In Kubernetes worker node, we have 4 more important components, and they are kubelet, kubeproxy, pod, and containers. First, we have kubelet. It is a primary node agent that runs on each worker node inside a cluster. It looks at the pod spec that was submitted to the API server on Kubernetes master and ensures that the containers are described in the pod specs are running and healthy. In case if kubelet notices any failures with the pods running on this worker node, then it tries to restart the pod on same node. Next, kubeproxy. Kubeproxy is a critical element inside Kubernetes cluster. It is responsible for maintaining the entire network configuration. It essentially maintains the distributed network across all the nodes, all the pods, and across all containers, and it also exposes services to the outside world on the internet. Next comes the pod. Pod is basically a scheduling unit in Kubernetes, just like VM in VMware world. So each pod consists of one or more containers. In most cases, there will be one container. So the primary advantage of pod is we can deploy multiple dependent containers together. So it acts as a wrapper around these containers. Finally comes the container. It provides a runtime environment for your applications. So you run containerized application processes inside these containers. So that's about the Kubernetes important basic components. Now we'll look at the process of creating Kubernetes master and the worker nodes. Finally, at the end, we'll deploy a sample application to make sure everything is working as expected. Now it's time to go through some of the steps involved in creating Kubernetes cluster with master and node. This is primarily divided into 2 subparts, that is, installing and testing. So before we go ahead with installation steps, let's review the prerequisites for setting up Kubernetes cluster using Kubeadm. So coming to the prerequisites, first thing, make sure the VMs that you're creating as part of this setup has at least 3 GB RAM and 3 virtual CPUs. These numbers are based on my experience. You might see these numbers a bit less on official documentation. And next requirement is to have a full network connectivity among all machines in the cluster between the master and the Kubernetes worker nodes. Next is to disable swap on all nodes. And the final requirement here is to disable SE/Linux. You have to do this until SE/Linux support is improved in kubelet. Now, let's take a look at the steps involved in creating Kubernetes cluster in next slide. In this slide, we'll discuss about the 6 steps involved in creating Kubernetes cluster. So in the first step, we'll create the VM which are part of Kubernetes cluster. In next slide, I'll show you how many VMs we'll be creating as part of this Kubernetes cluster. Then, we'll disable SC Linux and swap on all nodes. After that, we will install the 4 packages. They are Kubeadm, Kubelet, kubectl, and Docker on all nodes, including Kubernetes master and the worker nodes. And the point to note here is, Kubeadm will not install or manage Kubelet or kubectl for you. You have to manually do that. So once the installation is done, then make sure to start and enable Docker and Kubelet services on all the nodes. Then the fourth step is to initialize the master node. So during this process, all the required components will get installed and configured on the Kubernetes. So during this process, all the required components will be installed and configured on the master server. So can you guess what is a command to configure Kubernetes master node? If your answer is Kubeadm init, then it is right. So we'll initialize the master node with Kubeadm init. And once you configure the Kubernetes master node, and before you join Kubernetes worker nodes, and there is one more step, and that is configuring pod networks, where all pods can communicate with each other across all the nodes inside the cluster. So there are various network plugins to configure pod network. And some of the network plugins we can use are Wave, Flannel, and Calico. In our example, we'll install the Flannel here. Once that is done, the final 6th step is to join the worker nodes to the master node. Then we are all set to launch our applications on the Kubernetes environment. So before we move on to the next slide, you might want to pause this video and observe these 6 steps again. These are the exact 6 steps that we are going to perform in this video. I believe you are good with it. And let's move on to the next slide. This is how our setup will look like. As you can see, we'll create 4 CentOS VMs with minimum of 3 CPUs and 3 GB of RAM. And for master node, maybe you might want to have a bit higher configuration. In our example, have created all these 4 VM instances on Google Cloud. In that, one VM will be configured as master node and other 3 will be configured as Kubernetes worker nodes. So that's about the setup will look like. Now, let me show you the 4 VMs I have created inside Google Cloud. So here is a snapshot of 4 Google Cloud VM instances. So creating this VM is very simple. I'm guessing most of us are familiar with it. In case if not, don't worry. I have that covered in the demo. As you can see, all 4 VMs has internal and external IPs. You can log into the server by clicking on the drop-down next to SSH. Personally, I prefer connecting using Cloud Shell to connect to these VMs. Once you have the VMs created, then next step is to disable swap and SC Linux, which is step 2. In this slide, we'll first disable swap, then SC Linux on all nodes, and finally we'll reboot the VMs to make sure it comes clean. So to disable swap, we'll use the swap off command with the -a option. Also, check there is no swap related entries in FS tab. If there are, please do remove or comment it out. And one of the main reasons why we need to disable swap is the performance related. Next thing is disable SC Linux. You can do that by using set enforce 0 command. For SC Linux to disable permanently, you need to update config in SC Linux config file as shown above. So you have to disable SC Linux until SC Linux support is improved in the kubelet. You need to disable SC Linux and swap on all nodes including Kubernetes master and worker nodes. Once that is done, it is good to reboot all the nodes to make sure it comes up clean. And make sure swap and SELinux are disabled post reboot. So that's about the swap and SELinux. Next comes the installing Docker. Kubernetes supports multiple container engines, such as Docker and Rocket. Since a Docker is most popular and widely used container engines across, so we'll go with installing Docker. If you are using CentOS VM on Google Cloud, then please go ahead and install Docker using yum install, as you see in the screen. In case if you are using Ubuntu, you need to use apt-get command instead of yum. You can find those commands on Kubernetes documentation or just Google for installing Kubeadm. After successful installation of Docker, start the Docker service and enable the service to start at boot time. We need the Docker container engine on all servers, including master and the worker nodes. So you need to install the Docker and then start and enable Docker service on all servers. Once that is done, then we can install other three applications, which are Kubeadm, Kubelet, and kubectl. I guess you are already familiar with what this software application does. But just a quick review if you forgot this. First, Kubeadm. It is responsible for bootstrapping the Kubernetes cluster. Next, Kubelet. This component runs on all machines inside your cluster and does things like starting pods and containers. Finally, kubectl. And this is a command line utility through which we can manage the cluster, such as creating, deleting, displaying, and updating various Kubernetes objects. So all these packages are not available in default OS repository. So we need to create one repo file inside repos directory. This repo file consists of a location where all above 3 Kubernetes related packages are available. Once you have the repo file in place, then you can start installing all 3 packages using yum install on CentOS and then start and enable Kubelet service. You need to perform this on all VMs, including Kubernetes master and the worker nodes. In case if you are setting up Kubernetes on RHEL and CentOS, then there is one more extra step need to perform. And that is this. This is used for fixing issues where traffic is being routed incorrect due to IP tables being bypassed. So go ahead and update config as you see on the screen. Once you're done with it, now let's move on to the next step where we will initialize Kubernetes cluster. Configuring Kubernetes master node is very simple. It is just one simple command. We can do that by Kubeadm init command as you see on the screen. I guess you might be wondering what is that pod network thing here? This is required if you wish to use Flannel pod network add-on. If you ignore this, then kubedns pod will not start. We'll talk about this pod network in next slide. For now, use the exact command to set up the Kubernetes master node. So upon successful execution, we should see something output which is similar to this. In the command output, you will see 2 things. First, we need to execute these 3 commands as a regular user in order to start using kubectl command. Second, it will print join command. You need this command to execute on worker nodes to join them to the cluster. We need this for the future purpose. For now, you need to save it at some secure place. You will see me using this command in a second. So that's all with initializing the node as a master node. Now, moving on to the next slide where we talk about configuring pod network on master node. It is required to install a pod network plugin after you initialize the master node. So it will help the pods to communicate with each other. It is necessary to do this before you try to deploy any applications on your cluster and before kubedns starts up. And there are different types of network plugins as we discussed previously. In this case, we are using Flannel network plugin. If you remember, we have used pod network CIDR to the Kubeadm init command in the previous slide. That's because it is required if you're using Flannel network add-on. So you can install pod network using kubectl apply command followed by kubeflannel YAML file as you see on the screen. So to confirm if pod network is installed, you can do that by checking kubedns pod is running by using kubectl get command. That's about the pod network. Now the final last sixth step, and that is joining worker nodes to the cluster. It is very simple. So to join the worker nodes to the cluster, we need the join command we noted down from Kubeadm init command output in previous slide. Here is a join command that was provided to us during initializing the master node. So just execute this exact command on worker node to join to the cluster. So upon successful execution, node will join the cluster. It is that simple. And the token in join command expires after 24 hours. In that case, you can create new tokens by using Kubeadm token create print join command as shown above. It is advised you to not to use this frequently as it will create new tokens every time you run it. So now we have Kubernetes master and the worker nodes and all components are configured and ready. And now it's time to make sure everything is working correctly, and for that we'll test with deploying a sample application in the next slide. Currently we are on the master node. So to display the nodes inside the cluster, we'll use the kubectl get node command. As you can see from the output, we have 4 nodes. One is master and 3 are worker nodes, and all are in ready state, which is what we are expecting. Overall, cluster looks healthy and working perfectly. Now, let's deploy a sample application and check if there are any issues with it. So to create a deployment, we'll execute the kubectl run command followed by sample application. From the command output, it is confirmed that deployment has been created successfully. Now, to display the pods which are created as part of this deployment, we will run the kubectl get command. As you can see, there is one pod which is created and running successfully as part of this deployment. Based on above testing, cluster is running with 3 worker nodes and we are able to deploy sample application successfully. So far in this video, we have discussed about what is Kubeadm and what are some of the commands related to Kubeadm and what are the 6 steps that are involved as a part of configuring Kubernetes cluster using Kubeadm. So before we end this video, let's review some of the important points that we discussed in the last few minutes as part of the summary. So coming to the summary, in this video, we first discussed what is Kubeadm and what it does. So Kubeadm is a command line utility which helps us with installing and configuring Kubernetes cluster. Then we discussed about Kubeadm commands such as Kubeadm init to initialize the Kubernetes cluster, Kubeadm join to join the worker node to the cluster, and more. After that, we discussed about the 6 steps involved in creating Kubernetes cluster. They are: first, we need to create the VMs. In our case, we have created 4 CentOS VMs, where 1 is master and 3 are the worker nodes. So once the VMs are up and running, then we disable SELinux and swap on all nodes. After that is done, we install the Docker, Kubelet, Kubeadm, and kubectl on all nodes and make sure Docker and Kubelet is enabled and started on all nodes. Then we initialize the master node with Kubeadm init command. After that, we configured pod network add-on on master node. So we use Flannel in our setup. Finally, we have joined worker nodes to the cluster by using Kubeadm join command. So those are the 6 steps that are involved as a part of configuring Kubernetes cluster using Kubeadm. And we also did some testing to make sure our setup is correct. And it did work as it should be. So that's about configuring Kubernetes cluster using Kubeadm. And now coming up, the actual demo, where we will perform exact steps to configure Kubernetes using Kubeadm. And thank you so much for watching this, and I hope to see you in the next video. In virtualization space, basic scheduling unit is virtual machine. And in container space, it is container. So in Kubernetes, what is a basic scheduling unit? Hello and welcome to Pods. So in next few minutes, I'll try my best to get you up to speed on what are pods in Kubernetes and what is the difference between container and a pod and how to create pods in Kubernetes. Before you watch this video, it is required to have a basic understanding of what is Kubernetes and its basic architecture. So, without any further delay, let's take a look at the things you'll be learning as part of this video. In this video, we'll primarily focus on discussing the concepts around pods. First, we'll start with discussing what is a pod. Then, we'll discuss how pods are deployed in Kubernetes. After that, we will see in what instances we will use multiple containers in single pod. Then we will look at how does the pod networking works. And after that, we will discuss about what is interpod networking and what is the intrapod networking. Then we will look at the various stages of pod lifecycle. And finally, we will look at how to write pod manifest file. So this video is pretty much packed with the concepts around pods. And it is very important to understand all these concepts very well. Because Kubernetes revolves around pods. So it's very important to get the basics straight, and then it will help us to build related concepts easily on top of it. And let's get started with discussing what is a pod. So what is a pod? Pod is an atomic unit of scheduling in Kubernetes world. So to better understand what this atomic unit of scheduling, we'll have to take a step back and look into some of the familiar topics. They are virtualization and containerization. So when you get into the virtualization world, the atomic unit of scheduling is virtual machine. If you want to deploy any app, then you need to put your code and related config inside the virtual machine and then deploy it. Next, when it comes to the containerization world, generally you use containers. And in the same way, we use pods in Kubernetes world. Virtual machines, containers, and pods are different runtime environments using which we deploy the application. So at a high level, pods are basic unit of scheduling in Kubernetes. Now, we'll look at how these pods are deployed in next slide. In this slide, we'll go through how the pod is deployed and scaled inside Kubernetes cluster. First, to deploy the pod, we generally write the pod manifest file, which consists of container images that we are able to deploy and submit to the API server on the master node. After that, API server and the scheduler components on master nodes decides and deploys these pods onto appropriate worker nodes. As you can see, inside each pod, there is one container in our deployment. And now, let's take a step back here. Generally, our ultimate aim is to deploy our app in the form of containers that are distributed across a set of worker nodes inside the Kubernetes cluster. However, Kubernetes does not deploy containers directly on the worker nodes. Instead, containers are encapsulated inside a pod. As you can see, there are 3 instances of the same app running on worker node. As the time passes, users accessing the web app increases, and then we need to scale the app as the demand goes up. Now, you need to add additional instances of your web app to share the load. So the question here is, how do you scale this app now? If you are thinking adding new container within the same pod, then answer is no. That's not how we do it. we create new pod altogether with the same app instance. As you can see, we just deployed 5 new instances of our web app running on 5 separate pods on same Kubernetes system. And the second question is, what if the number of users accessing the web app further increases and your current node has no sufficient capacity? Well, then it's time to spin up a new VM and join that new worker node to the cluster. Once it is ready, Kubernetes will start deploying pods onto this new node. From this, there are 2 takeaway points. First, typically there will be 1 container per pod. Second, to scale up your app, we need to create more pod instances. Similarly, to scale down, we'll do that by deleting the pods, and we do not interact with containers directly. So that's about the deployment. So far we talked about having one-to-one relationship between pod and containers. But it is possible to have 2 or more containers inside a pod, and which is a rare scenario. And this is called as multi-container pod. We'll discuss about what is multi-container pod and what are some of the situations that will drive us to use more than 1 container per pod in next slide. Here is the same diagram which we carried from previous slide with some minor corrections to it. So, in what cases do we use multiple containers inside of one single pod? For sure, not to create another instances of an application. If not, then what? Sometimes you will come across a scenario where you have a helper container that might be doing some kind of a supporting task for our main web app, such as processing a user entered data or processing a file uploaded by user or etc. And you want this helper container to live along the side of app container. So in that case, you can have both of these containers part of same pod, so that when a new app container is created, the helper container is also created. And in the same case, when the app container dies, then the helper container also dies, because they are part of same pod. So these 2 containers can also communicate with each other directly by referencing using a local host, because they share the same network namespace. Plus, they can also easily share the storage space as well. However, multi-pod containers are a rare use case, and we are going to stick with a single container per pod for the rest of the course. So that's about the multi-container. Now, let's discuss about the pod networking in next slide. As you can see in this diagram, we are having 2 pods, pod 1 and pod 2, which are running on worker node inside the cluster. Pod 1 has 2 containers and pod 2 has just 1 container. For simplicity purpose, I did not show the node and the cluster explicitly in this diagram. So if you observe this diagram, you will notice something new in this diagram. If your answer is pod IP address, then you're right. As most of us are aware, every node inside the Kubernetes cluster has its unique IP address, which is called as node IP address. But in Kubernetes, there is additional one more IP address, which is called as pod IP address. So once we deploy the pod onto the worker node inside the Kubernetes cluster, it will get its own IP address. So every pod inside a Kubernetes cluster has a unique IP address for that pod. So if you look at the example we got here, we got 2 pods and 2 IP addresses. And we have 1 IP per pod. So how are these containers inside the pod communicate with outside world? And there is something called as network namespace. All these containers inside a pod operate within that same network namespace as a pod, which means all these containers inside the pod will have the same IP address. But there should be one distinct thing which will make the unique way to identify each of this container. That's where the ports come in. As you can see, the main container in the pod 1 has a port 8080. So it can be accessed using the pod IP and the port number 8080. Similarly, supporting container in pod 1 can access using the same pod IP and the port number 3000. Since these 2 containers are part of pod 1, so the IPs are same. Now, to access the container inside pod 2, we use a pod 2 IP address and the port number of the container. So that's how we access the applications deployed inside the containers, and pods are accessed from the outside world in Kubernetes. And there is one last thing to clarify before we move on to the next slide, and that is containers within same pod not only just share the same IP address, but it will also share the access to the same volumes, same cgroup limits, and even same IPC names. And that is something very important to note. So in next slide, we look at how one pod talks to another pod, which is called as interpod communication. Now in this slide, we'll discuss how two pods communicate with each other, which is called as interpod communication. Interpod communication is simple. That's because all the pod IP addresses are fully routable on the pod network inside the Kubernetes cluster. If you have watched me setting up Kubernetes using Kubeadm video in this series, which you might have done already, where you have seen me installing pod network plugin, which is called as a flannel, and I have used the CIDR IP ranges to create the pod network. Once you are done with that step, every pod gets its own IP address that's routable within that cluster. This means every pod can directly talk with every other pod, and there is no need to mess with any port mapping or anything. And there is no need to mess with any port mappings or anything. Well, that's about the interpod communication in short. And now we are going to talk about how the intra-pod network communication is going to work in the next slide. In this slide, we'll discuss about how two or more containers within the same pod communicate, which is also called as intrapod communication. We have touched this topic in previous slide, where you have two or more containers within the same pod and how do they talk to the outside world. One thing we didn't discuss is how do they communicate within same pod. Well, inside the pod, like if you got a multiple containers in there, they all talk over using shared localhost interface. So all containers can directly communicate with each other's port on localhost. Within the pod, they all share same IP address and the network namespace. And if you need to make multiple containers available to outside world, which is exposing to the outside world, then you need to expose them on ports. And obviously, if you got two containers inside a pod, then both cannot use the same port number. Still, normal networking rules applies here. So, speaking at a very high level, containers within same pod communicate inside using a shared local host. So that's about the intrapod communication. And now, let's see the various stages in the life cycle of a pod from start to end. In this slide, we'll discuss about the life cycle of a pod. First, you define the pod configuration inside a manifest file in YAML or JSON format. Most typically, you'll be using the YAML format. Then, you submit the manifest file at the API server on Kubernetes master. And once that is done, it will get scheduled onto a worker node inside the Kubernetes cluster. Once that is scheduled, it goes into the pending state. So during this pending state, node will download all the container images and starts running the containers. It stays in the pending state until all containers are up and running. Once that is done, it goes into the running state. So here in this running state, if the main purpose of the pod is achieved, then it gets shut down and the state changes to the succeeded. And there is one more stage, where the pod gets into the failed state. That happens when the pod is in pending state. If for some reason it won't get started, the pod will move into the failed state. And one last thing to note, when pod dies, it dies. You can't bring that pod back from dead. So if they die, you replace with a new pod. The old one is gone and the shiny new one with exactly the same config but a different ID, different IP, and all magically appears and takes its place. So that's about the various pod statuses during its life cycle. And now it's time to see what goes into the pod manifest file, and we'll see that in next part, which is review demo. Here in this part 2, we'll review the pods demo we are able to perform live on Kubernetes cluster in advance. So this will help you better understand when you watch actually doing it live. So in this review demo, I'll show you what goes inside the pod manifest file. Then we create the pod and we'll display and validate the objects to make sure it has created. And finally, we'll test the pod deployment to make sure it is working as it should be. And now, let's get started with creating the pod manifest file. We can define Kubernetes objects in two formats. They are JSON and YAML format. YAML has the cleaner and the most easy to understand than JSON. In our video, we will use the YAML format. So, most of the Kubernetes object consists of 4 top-level required fields. So, even in the pod manifest file, it contains the same 4 top-level fields. They are API version, kind, metadata, and spec. So, you must have them in your configuration file. So, let's see what they are. First, API version. API version defines the version number which this Kubernetes object belongs to. So I have made this table which explains about the kind of the object and its respective API version. It's important to remember this relationship, which will help us creating future objects. As you can see, there are different types of API version. So what this means? At a high level, if an API version is v1, then that Kubernetes object is part of first stable release of Kubernetes API. So it contains many of the core objects, which includes pod, ReplicationController, and service. So all these objects are part of first stable release of Kubernetes API. Then you see another API version, which is apps v1. It is one of the most common API group in Kubernetes. It includes the functionality related to running apps on Kubernetes, like deployments, rolling updates, and ReplicaSet. And the final API version in this list is batch v1. The batch API group contains objects related to batch processing and jobs like tasks. So, any functionality in Kubernetes starts with alpha, then it moves into the beta, and finally the stable. The stable API version does not contain alpha or beta in their names, as you see above in this list. So, they are safe to use. And now, let's get back to the pod configuration again. So the API version of pod is v1. Next, the kind of object we are creating here is pod. So pod is here. Next comes the metadata. Metadata section consists of 2 fields. One is name, other is label. As you guessed it right, name is the name of the object we are creating. In this case, it is the name of the pod, which is Nginx pod. Second, we have labels. Labels are just a tag given to the pod. This labels comes very handy when it comes to filtering. Assume there are thousands of pods running inside your Kubernetes cluster. And now you want to filter all the pods that related to Nginx. Then labels come very handy in those situations. However, label is an optional field, but my personal recommendation is to have labels defined almost always. So far, we have defined about the type and the name of the object we are creating. Next comes the spec. As I mentioned in our pod discussion, pod is nothing but a wrapper around one or more containers. So, pod consists of one or more containers. And now it's time to define the container configuration under this spec file. Since this is an Nginx example, so we are going to deploy Nginx container from Docker Hub. The name of the container we defined here is Nginx container. And the image we are using here is Nginx. Since we are not giving any specific Nginx version, so it is going to download and install the latest version of Nginx. Under the image, you can give the environment variables for this container and commands to run when the container is started if needed. But we are skipping that step. So that's all it is. It's very simple and straightforward. So once you deploy this config, it will create one instance of Nginx container inside your Kubernetes cluster. And now let's go ahead and deploy this pod configuration inside our Kubernetes cluster. In this slide, we'll create, display, and verify pod object. Since our nginx pod manifest file is ready, let's go ahead and deploy that pod. To do that, we use kubectl create command, which is followed by the name of the pod, which is nginxpod.yaml. And the output confirms that pod is successfully created. Next, to verify the pod is running or not, we'll use the kubectl get pod. So it will list all pods inside your Kubernetes cluster. So in case if you want to display the specific pod, we can use the pod name after kubectl get pod. As you can see, pod status is successfully running and there are no restarts, and it has been 2 minutes since it is created. As we know, every pod has a unique IP address. So to know the IP address of a pod in the node which this pod is running, we need to print the void output of it. We can do that by using kubectl get pods followed by void option. As you can see, pod has the IP address of 10.240.1.26 and it is running on node 1. And next cool feature about kubectl get command is it can print the object configuration in YAML or JSON format. So let's print our pod config in YAML format. To do that, we just add YAML option at the end of the kubectl get pod command. And you can see the YAML format of the pod object that we just created. So this is how we create the pod object and display higher level details of pod. So next, we'll see how to display the detailed output of nginx pod in next slide. Kubectl describe will display all the details of the pod, which includes list of all events from the time pod is assigned to the node till the current status of the pod. Now, to display the details of our nginx pod, we will run the kubectl describe pod command followed by the pod name, which in this case nginx pod. As you can see from the output, it will print the name of the pod, node on which pod is running currently, when it started, labels of this pod, current status which is running, then the pod IP, and finally list of all events of nginx pod. This command comes very handy during troubleshooting. Next, we'll perform some basic testing to make sure pods are accessible in next slide. Here, we'll verify if the connectivity from the master node to the pod is working or if there are any issues. For that, we need the pod IP. You can get that from kubectl describe command or kubectl get command that we just saw. In our example, pod IP is 10.240.1.26. So let's ping that pod IP. As you can see, connectivity between the master node and the pod is working perfectly alright. Next, let's get inside the pod and execute some commands. For that, we need to get the shell prompt. And here is a command. Here, -it is the command that refers to the interactive shell, and the type of shell need is bash sh. So after you run this command, now we are inside the pod. So let's find out the host name of it. As you can see, nginx pod is a host name. Now, to get outside of this pod, we'll use the exit command. Finally, let's delete this pod that we just created. For that, we'll use the kubectl delete command. As you can see from the output, the pod has been successfully deleted. So far in this video, we have created the pod manifest file, then we displayed, then tested, and finally deleted. So before we end this video, let's recap all the things that we just discussed in this video so far. Coming to the summary, in part 1, we discussed the concepts around Kubernetes. First, we discussed what is pod in Kubernetes. So pod is the atomic unit of deployment in Kubernetes, just like similar to VM in virtualization and containers in containerized world. Then we discussed about how we deploy pod and scale it as per the demand increases. After that, we discussed about what is multi-container pod and its purpose. Then we discussed about pod networking. As I mentioned, every pod inside Kubernetes has their unique IP address. Containers inside the pod share the same IP address as pod IP. containers are exposed to the outside world on its ports. After that, we discussed about the inter-pod networking. It is a communication between two pods. As we discussed, every pod IP address is routable inside the cluster. Then, we discussed about intra-pod networking, where two or more containers inside the pod communicate with shared local host. So all these containers within the same pod share same common IP address, volumes, network namespace, and IPC. After that, we discussed about various states in lifecycle of pod. So as soon as the pod is scheduled on the worker node, then pod will be in pending state. Then it will move into the running, and finally succeeded state. So if the pod has any issues starting during the pending state, it will move into the failed state. And that's about the part 1. And coming to the part 2, we first discussed about the pod manifest file. Then we created the pod and displayed it and validated the objects to make sure it has created successfully. And after that, we tested the pod deployments to make sure it is working as it should be. And yes, it did. And finally, we deleted the pod object that we just created. Now, moving on to the next video, which is actual demo of pods on live Kubernetes cluster, where we will perform the exact steps that we just discussed in review demo section. And finally, thank you so much for watching this. Hope to see you in the next video. Hello and welcome to pods demo. In pods concept video, we have discussed about what is pod, how multiple pods communicate, and what are some of the use cases of it, and more. I hope you have watched that video, and with that, let's get started discussing the high-level overview of this demo. This demo is primarily divided into 3 steps. In step 1, we will go through the pod manifest file. Then in step 2, we will deploy a sample Nginx app inside the pod. And once the object creates, then we will display and validate pod using kubectl get and describe command. And finally in step 3, we will create the custom test page inside the Nginx pod. After that, we will expose this pod to the outside world on the internet using nodePort service. And finally, we will access this test page that we created inside the Nginx pod externally on the internet and internally from nodes inside the Kubernetes cluster. After testing, we will clean up the objects we have created in this demo. So that's the high-level overview of this demo. And before we start reviewing the pod manifest file, let me show you my Kubernetes cluster setup that I'm using for this demo. This Kubernetes cluster setup that we are using for this demo consists of 1 master node and 3 worker node VMs. All these 4 VMs are running on Google Cloud with CentOS 7 operating system. We are connecting to these VMs using Cloud Shell. And finally, let's go ahead and check the status of these nodes by running kubectl get nodes command. As you can see from the command output, we have 1 master and 3 worker nodes. All 4 nodes are online and running successfully. For more details on this Kubernetes cluster setup, please refer to the Installing Kubernetes using Kubeadm video. And now, let's get started with the first step in this demo. Coming to step 1. So in this step, we will review the pod manifest file with Nginx container. And let's get started. First, let's get into the pod working directory where we have the manifest file. There is only one pod manifest file that will be working in this demo. And let's open that file and go through it. Like most of the Kubernetes objects manifest file, pod manifest file consists of 4 top-level required fields, which includes API version, kind, metadata, and spec. So you must have them in your configuration file. Let's go through what these files are one by one. First, API version. API version defines the version number which this Kubernetes objects belongs to. So the API version of pod is v1. Next, the kind of object we are creating here is pod. So we have it here. Next comes the metadata. Metadata section consists of 2 fields. One is name, other is label. Name of the pod is Nginx pod. Second, we have labels. Labels are used to logically group all related pods together for displaying and managing. These labels comes very handy when it comes to filtering. For example, if there are thousands of pods running inside your Kubernetes cluster and you want to filter only Nginx pods, then these labels comes very handy in those situations. However, label is an optional field, but my personal recommendation is to have labels defined almost always. Next comes the spec section. As I mentioned in our pod concept video, pod is nothing but a wrapper around the container. Pod can have one or more containers. Generally speaking, you will come across only one container per pod in most of the cases. Since this is an Nginx example, so we are deploying Nginx container from Docker Hub. Name of the container we defined here is Nginx container. And image we are using here is Nginx. Since we are not giving a specific Nginx version, it is going to download and install latest version of Nginx. Under image, you can give the environment variables, port numbers, and volumes for this container. Since this is the first video in this Kubernetes series, so let's keep it simple. And that's all it is. It's very simple, right? Now, let's exit from this file and create a pod config as part of step 2. In step 2, first we'll deploy the pod using kubectl create command. Then, we will validate pod status using kubectl get command. And we'll print complete details of this pod using kubectl describe command. Let's go to the console and start creating our first Nginx pod. First, let's make sure if there are any pods running inside this Kubernetes cluster by running kubectl get pods command. As you can see, there are no pods. Now, let's go ahead and deploy that pod using kubectl create command followed by name of this manifest file in our example. And the output confirms the pod is successfully created. Now, let's verify the pod status by running kubectl get pods command. So this command will display all pods inside the cluster. In case if you want to display a specific pod, we can use the pod name after kubectl get pod command. Now, let's run that kubectl get pods command to display all pods running inside this Kubernetes cluster. From the output, you can see Nginx pod is successfully running and there are no restarts. And it's been 2 minutes since it has created. Currently, we have 3 worker nodes inside this cluster and some of you wondering on which node this pod is running on. You can find out by running kubectl get pods command with wide option. So let's go ahead and run that command. From the output, you can see Nginx pod has the IP address of 10.240.6.11 and it is running on worker 3. And one more cool feature that kubectl get command has is it can print the any object configuration in YAML or JSON format as and when needed. Let's hypothetically assume that your original manifest file has lost somewhere and you have this Nginx pod running inside your Kubernetes cluster. And now let's print our Nginx pod that is currently running in YAML format using kubectl get pods command. There you see the Nginx pod configuration in YAML format. And this is useful when you want to display every minute details of running object. So far, we have seen how to display higher level details of pod. And now, let's print the complete details of the pod by running kubectl describe command followed by pod name. You can see the pod is running successfully on worker 3 and it has the IP address ending with 11, and then you see the Nginx container is running inside this pod, and finally you see the list of events from the beginning. This command comes very handy during troubleshooting. So far, we have successfully deployed pod and confirmed the pod is running successfully, and now it's time to move on to the step 3, where we will be doing some testing. After that, we'll clean up the objects that we have created in this demo so far. Coming to final step 3, we are going to create a sample HTML web page inside Nginx root directory. After that, with the help of nodePort service, we will expose this app to the outside world. At this stage, it's okay to not know much about this nodePort service. We will discuss about that in depth in later part of this course. So, once the app is exposed to the outside world onto the internet, then we will access this previously created test.html web page, and also will access the default Nginx web page using node IP and nodePort from any web browser. In case if you're not familiar with what is this node IP is, it is an external IP address of any master node or any worker node inside the Kubernetes cluster. Besides accessing this web page from the internet, we'll also access this HTML web page internally from the worker nodes inside Kubernetes cluster using pod IP. Finally, after testing, we'll clean up the two objects that we have created in this demo. They are pod and nodePort service. So let's get started. So to create test.html page inside Nginx pod root directory, we need to get inside the pod. We can do that by running kubectl exec command as shown here. So let's go ahead and run it. And now we are inside the pod. So let's execute the host name. And it displays the pod name, which is Nginx pod. Now let's go ahead and create our test.html page inside the Nginx root directory. And it is done. Now let's exit from this pod and expose this pod using nodePort service. And we'll create this nodePort service using kubectl expose command. So let's go ahead and run that command. And we have successfully exposed Nginx pod to the outside world using nodePort service. Now we need to know the nodePort number on which this Nginx web page is exposed to the outside world. You can get that by running kubectl describe command. So let's go ahead and run that command. From the command output, you can see the nodePort is 3758. So to access this web page from the web browser, we need node IP and nodePort. As we have the nodePort, we now need to know the node IP. As I mentioned earlier, this node IP is the external IP address of Kubernetes master or any worker node inside this Kubernetes cluster. So for now, let's go ahead and take the worker node 3 external IP address. Here it is. Let's copy that. And now let's go ahead and get the nodePort. Here it is. And there you see the default Nginx web page. Please note, IP address and port number that you're seeing here on the top is called as node IP and nodePort. So as I mentioned earlier, node IP is a publicly routable external IP address of any worker node or a Kubernetes master. In this case, it is worker 3 external IP address. And we got the nodePort by exposing the Nginx pod using nodePort service. And now let's access our test.html web page that we created inside the pod. And there you see our test.html page accessing externally on the internet. Now let's access this web page using other node's external IP address. However, this nodePort number will remain the same. This time, let's test using the worker 1 external IP address. Yes, you can still access the web page. Now, let's try with the master node external IP address. you are successfully accessing the web page using master node external IP address. So from above test results, we are successfully accessing the test.html externally from the internet. Now, let's access this web page internally from Kubernetes cluster. For that, we need pod IP and port number. You can find that info from kubectl describe command followed by service name. Here it is. Now, let's copy that endpoint IP address and the port number. Now, first run the curl command followed by endpoint IP address master node, and we are successfully accessing the default Nginx web page. Now let's try accessing the test.html web page. There is your test.html page when trying to access using pod IP and port number. Now, let's try to access the same test.html page from all three worker nodes. And we are successfully accessing the test.html internally from all nodes inside the Kubernetes cluster. So from above test results, we are successfully accessing the test.html web page that we created inside the pod, externally from the internet and internally from the Kubernetes cluster nodes. Now, it's time to clean up the things here. So in this demo, we created two objects. They are pod and nodePort service. Now, let's go ahead and delete the pod and service by running kubectl delete command followed by pod name and service name. And we have successfully deleted our Nginx pod and service. So to make sure, let's run the kubectl get command. As you can see from the output, there is no Nginx service and pod that we created earlier in this demo. And this cluster is back to the clean state, where it was before we started the demo. And before we end this video, let's review the steps we have gone through in this demo for one last time. In step 1, we have gone through the pod manifest file. Then in step 2, we deployed a sample Nginx application inside the pod. And once the object has created, then we displayed and validated pod using kubectl get and describe command. And finally in step 3, we created a custom test page inside Nginx container. Then exposed the pod to outside world onto the internet using nodePort service. And finally, we tested by accessing test.html web page externally on the internet and internally from all nodes inside the Kubernetes cluster. After testing, we have deleted the objects that we have created in this demo. They are service and pod. And that comes to the end of this demo. Hope you have enjoyed it and see you in the next video. Thank you. Let's imagine that you want to deploy a containerized app inside Kubernetes cluster. So, how can you ensure that at least 3 instances of pod is always available no matter what? Hello and welcome to ReplicationController. So in next few minutes, I'll try my best to explain what is ReplicationController and what are the advantages of it. But before you watch this video, it is required to have a basic understanding of what is Kubernetes, pods and kubectl. So without any further delay, let's take a look at the things you'll be learning as part of this. This presentation is divided into 2 sections. In first section, we'll discuss the concept around ReplicationController. What is ReplicationController and what it does. Then we'll discuss the advantages of ReplicationController. And finally, we'll discuss about the ReplicationController manifest file. After that, we will review the demo we are about to perform on live Kubernetes cluster in advance. So this will help you better understand when you watch actually doing it live. In this review demo, I'll show you how you can deploy application using ReplicationController. Once the application is deployed, then we'll display and validate the objects it has created. After that, we'll test the deployment by scaling up and scaling down the application. And finally, we'll clean up the objects that was created as part of this deployment. If you're looking for the actual demo on performing above steps on live Kubernetes cluster, then you can refer to the links in the description below. Now, let's get started with what is ReplicationController and what it does. So, what is ReplicationController exactly? ReplicationController ensures that a specified number of pod replicas are running always. In other words, if we define there should be 5 pods running at any time using ReplicationController, then this controller will make sure these 5 pods are running always. In case if there are too many pods running than what was defined in the manifest file, then ReplicationController will terminate the extra pods. And in the same way, if there are pods running less than what is defined in manifest file, then ReplicationController will start more pods. Sometimes pods do fail, deleted, or die for various reasons. When they do, if it is backed by ReplicationController, then these pods will get automatically recreated. So there will be a situation where you want to just run only one pod all the time. Then in that situation, you need to define the replica count as 1 in the manifest file, so that ReplicationController will always ensure that pod is always available. It's actually a good idea and a best practice to create a ReplicationController with count as 1, which means even if the only pod that is running gets crashed or gets killed, then ReplicationController will get that back. One very important point to note here is how do this ReplicationController are aware of the pods that it needs to manage? And what is the link between ReplicationController and the pods that it needs to manage? Any guess? Answer is labels. Labels are nothing but a tag that was given to pod. So using labels, we'll relate the ReplicationController to pods that it needs to manage. Here, we will mention the exact labels inside the pod and the ReplicationController. ReplicationController is often abbreviated as RC or RCS. So that's about the ReplicationController at a high level. In short, ReplicationController ensures that desired number of pods are maintained always, given that number is 1 or 2 or more. And now, let's take a look at the 2 advantages of ReplicationController. First, high availability. Here is this diagram, and we have a 2-node cluster with node 1 and node 2. For some time being, let's forget about ReplicationController and everything. Let's assume we have deployed application inside one pod, and it is running and all good for some time. And all of a sudden, pod becomes inaccessible and dies for some reason. So when that happens, users lost access to it. So to avoid this kind of issues, we can use a ReplicationController and have a replica count to 2. If we deploy this config, then it creates 2 instances of same pod. Let's assume one pod is running on node 1 and other pod is running on node 2. Assuming there was some hardware problem on node 2 and the node went down, then in that case, pod on node 2 also dies with it. Can you guess what happens here? So here control manager on the master node detects these changes and it looks for the healthy node. Here in this case, it tries to create pod on node 1 within a matter of 2 to 3 minutes. So this is all happening in the background automatically. And now you have your high availability back. So that's how you can manage high availability with ReplicationController. Of course, you can use ReplicationController with replica count as 1. In that case, it will monitor one pod and recreates if it dies. Load balancing. I believe most of us are aware what is load balancing. For those who are not, generally it is a way of distributing incoming traffic from outside world to the application instances which are inside your infrastructure. There are different ways you can distribute the traffic. For the sake of this discussion, let's assume we want to distribute traffic equally among all the application instances. This way, traffic is equally distributed among all the application instances. So the end result here is we can serve user requests at the earliest possible and thus the better performance. In short, it is a way of balancing the load between multiple application instances. So that's about the load balancing at a very high level. Now coming to our topic, how this can be done in Kubernetes using Replication Controller. In this diagram, we have a Kubernetes master on the left and the worker node cluster on other side. And there is one node running inside this cluster. Let's take a scenario. Let's assume that you're releasing a new web app. Initially, you want to deploy with one instance and then scale up based on the number of users. As you can see, using Replication Controller, we have scheduled application with just one instance on node 1. After a while, you noticed an increasing number of users who are trying to access the application. Then you recognized it, and it is time to bump up the instances to give them faster response to end users. To do that, you need to increase the replica count to 3 in Replication Controller spec file. Once that is updated, Replication Controller will spin up another 2 new containers inside the node 1. And now the traffic is equally distributed among all 3 instances. So now let's imagine that on node 1 ran out of all resources such as CPU, RAM and the disk. Then we need to spin up another node and join that node to the cluster. As you can see, we have a brand new node 2 available inside the cluster. Now, if we increase the replica count from 3 to 4, then the pod will get rescheduled on node 2. That way, load is equally balanced among all the pods and nodes inside the cluster. And there is one last thing about Replication Controller, and that is, Replication Controller is old. It is replaced by new ReplicaSet. ReplicaSet is a next generation Replication Controller. As of this recording, there is only one difference between them, and that is, Replication Controller supports equality-based selectors, and whereas ReplicaSet supports set-based selectors. Besides that, whatever we discussed in this video so far is still applies to ReplicaSet. We'll discuss about what is this equality-based selector and what is the set-based selectors in the next video, which is ReplicaSet video. Before we move on to that ReplicaSet video, let's deploy a sample application using Replication Controller video. First, let's review the demo we are about to perform on live Kubernetes cluster in few minutes. In next few slides, we'll review the demo we are able to perform on live Kubernetes cluster. First, we'll see what goes inside the Replication Controller manifest file. Then, we'll deploy the application using Replication Controller. After that, we'll display the Replication Controller to make sure it is created as per our expectations. Then, we'll start testing a couple of scenarios to make sure it is working as per expectations. First scenario is, when node fails, the Replication Controller will recreate new pods on a healthy node inside the Kubernetes cluster. Second scenario is, we'll assume that there is a surge in traffic. So we'll scale up the application instances running inside the cluster. And the final scenario here is, we'll scale down the application instances, assuming the traffic returns to the normal. And now, let's start with writing manifest file for Replication Controller. Like any other Kubernetes object config file, Replication Controller contains 4 top sections. They are API version, kind, metadata, and spec. First, API version. Replication Controller is part of initial stable release. So the API version of Replication Controller is v1. Then kind. Kind of the object that we are creating here is Replication Controller. So we have it here. Then follows the metadata. Metadata contains 2 important things. They are name of the object and the label. Here, name of the Replication Controller is nginx-rc. You can define the labels for this Replication Controllers if needed here. But for now, we'll skip it. Finally, we have a spec section. Can you guess what goes here? If you remember the purpose of Replication Controller, you will get the answer. Answer is replicas and pods. Replicas will have a number of pod instances that you want to create. In our example, we have 3 pod replicas. Next, we need to define the pod configuration. We do that under template section. This section is exactly similar to pod manifest file, except API version and kind. Now the question here is, how do this replication controller will get to know about these pods? Any guess? It is using labels and selectors. We have already defined labels for the pod, which is app:/Nginx app. Here, Nginx app is the label. Next, we need to define the selector. Selector selects the pod with labels Nginx app. So we copy the exact labels under the selector. That's it. We are done. It is very simple, right? So to summarize this, we have 4 top-level sections, which are API version, kind, metadata, and spec. Under spec, we have defined number of replicas and pod configuration and selector. So now, let's go ahead and deploy this Nginx app using the replication controller. So to deploy, we use kubectl create command, followed by manifest file name, which is nginxrc.yaml file. So once you run this command, you should see nginxrc replication controller is created successfully. We use kubectl get command followed by pods to display the pods it created. As you can see, there are 3 Nginx pods which are created by nginxrc replication controller. And its status shows all 3 pods are running successfully, which is what we are expecting. Let's imagine that there are 100 other pods which are running inside your cluster. Now, if you want to just display the Nginx pods, then how can you just display that? Answer is using labels. All we need to do here is to filter the pods whose labels are tagged with Nginx app. We can do that by adding Nginx app label at the end of the kubectl get command, just like this, so that it displays all the pods which has a label of Nginx app. So now let's print the complete details of nginxrc replication controller. For that, we use describe command for that. We'll see more about on that in next slide. We use kubectl describe command to display complete details about specific replication controller. In this example, we are displaying nginxrc replication controller. There you see the labels and selectors of the pod, then the status of the pods, where all 3 pods are running and 0 failed. Next comes the pod template, which has a list of containers this pod has. As we see, there is only one Nginx container inside the pod. Finally, you can see the list of the events, where it shows all 3 pods are created successfully. And this is a very important command when it comes to troubleshooting. So far, we have created replication controller, then we displayed and verified to make sure it is working. And now, let's test some use cases of replication controller. First, we'll test how pods are rescheduled when underlying host dies. First, let's print on which nodes our pods are running inside the cluster. We can do that by using kubectl get pods with wide option. As you can see, there are 3 pods running on 2 nodes, node 1 and node 2. So for our testing, I'll manually go ahead and shut down node 2. Now, let's test to see what happens to the pod if node 2 dies. So now to make sure node 2 is down, we'll run kubectl get command followed by nodes. As you can see, there is a node 2 is now in not ready status. At this stage, let's give it few minutes to the master node. After some time, let's display the pods with wide output by running this command. As you see, the status of pod on node 2 changed to unknown and it recreated the pod on node 1. After some time, pod with unknown status will go off automatically. So this is what happens when node dies. Next use case that we're going to test is scaling up with replicas. Here in this use case, we'll scale up the application instances. Let's assume you notice there is a sudden increase in traffic from the end users accessing your website. Currently, there are only 3 app instances running, and it is getting burned down very fastly. Now, it's time to scale up the app instances by adding another 2 new app instances to the cluster. So to scale up the app instances from 3 to 5, we will use the kubectl scale command with replica option to 5. Once the command is executed, now let's display the replication controller to check how many instances are running. As you can see, there are 5 replicas currently running and they are in ready status. So it matches to our desired count, which is 5. Now let's execute the kubectl get pods command to display the number of pods currently running under control of Nginx RC replication controller. As you see, there is increasing number of pods from 3 to 5. There are 2 new pods created. In total, 2 pods are running on node 1 and 3 pods are running on node 2. So this is how we scale up app instances using the replication controller. And now let's see how to scale down the app instances in next slide. And once traffic comes down to normal, you can bring down the replica count to what it was there before. For that, you use the same exact process that we saw in previous slide. The only difference here is replica count to 3. So to verify that, we use kubectl get rc command to display. Here, rc is the short form of replication controller. As you can see, the desired and the currents are same, which is 3. Now it's time to clean up what we have created. So to delete the replication controller, we have to use kubectl delete command with -f option followed by manifest file we used while we are creating this. So this will delete all the objects which are part of this manifest file, which includes pods and replication controller. Please note, if you delete replication controller, it will delete all the pods which comes under its control. So now to make sure, let's display the pods with label Nginx app. As you can see, there is none. So far, we have deployed applications using replication controller, then we tested use cases of it. And now, before we move on to the actual demo, we'll review the important points that we discussed in the last few minutes. So coming to the summary, in first section, we discussed about what is replication controller. As we discussed, replication controller ensures that a specified number of pods are running at any time. Then we discussed how replication controller supports high availability and load balancing. After that, in review demo section, we discussed what goes inside the replication controller manifest file. Majorly, replicas and selectors are 2 most important fields which makes this special. Then we deployed the application using replication controller. Once the application is deployed, then we displayed and validated the objects it has created. Then we tested some of the use cases of deployment by scaling up and scaling down the application. And finally, we have cleaned up what we have created. And now moving on to the next video, and which is actual demo of replication controller on live Kubernetes cluster. In that demo, we'll perform the exact steps that we just discussed in the review demo section. And finally, thank you so much for watching this video and hope to see you in the next one. Let's imagine that you want to deploy a containerized app inside Kubernetes cluster. So, how can you ensure that there are at least minimum of 3 pod instances are always available and running no matter what? Hello and welcome to ReplicaSet. So in next few minutes, I'll try my best to explain what is ReplicaSet and what is the difference between ReplicaSet and a replication controller and more. But before you watch this video, it is good to have a basic understanding of pods, replication controller, and Kubernetes. So, without any further delay, let's take a look at the things you'll be learning as part of this video. This presentation is divided into two parts. In part 1, we'll discuss the overview of ReplicaSet. Then, we'll discuss about what are labels and selectors. And finally, we'll discuss about what is the difference between equality-based selectors and set-based selectors. And that's about the part 1. And now coming to the part 2, we will review the demo we are about to perform on live Kubernetes cluster in advance. And this will better understand when you watch actually doing it live. And in this review demo, we'll show you what goes inside the ReplicaSet manifest file, then how to deploy the application using ReplicaSet, and once you deploy the application, then we will display and validate the objects it has created. Next, we will test the ReplicaSet with some of the use cases, and finally, we'll clean up what we have created in this video. In case if you're looking for actual demo on performing above steps on live Kubernetes cluster, then you can refer to the link provided in the description below. And now, let's get started with knowing what is ReplicaSet and what it does. So, what is a ReplicaSet exactly? ReplicaSet ensures that specified number of pod replicas are always running at any point in time. In other words, if you define there should be 5 pods running at any time using a ReplicaSet, then this controller will make sure that these 5 pods are up and running always. In case if there are too many pods running than what was defined in the manifest file, then the ReplicaSet will terminate the extra pods. And in the same way, if there are pods running less than defined in the manifest file, then the ReplicaSet will start more pods. Sometimes pods do fail, deleted, or die for various reasons. And when they do die or deleted for any reasons, and if it's backed by a ReplicaSet, then these pods get automatically recreated on same node or another healthy node. So there will be a situation where you just want to run only one pod all the time. Then in that situation, you need to define the replica count as 1 in the manifest file. So that ReplicaSet always ensures that pod is always available. And it's actually a good idea and a best practice to create a ReplicaSet with count of 1, which means that even if the only pod that is running gets crashed or gets killed, then the ReplicaSet will bring that back. One very important point to note here is, how do these ReplicaSet aware of pods that it needs to manage? What is the link between ReplicaSet and pods that it needs to manage? Any guess? Answer is labels. Labels are nothing but a tag that was given to a pod. So using labels, we'll relate the ReplicaSet to pods that it needs to manage. Here, we'll mention the exact labels inside the pods and the ReplicaSet. We'll discuss more about labels and selectors in the upcoming slides. But before that, let's discuss about the controller that comes close to the ReplicaSet, which is ReplicationController. So, what is the difference between a ReplicationController and a ReplicaSet? ReplicaSet is the next generation of ReplicationController. ReplicationController and a ReplicaSet both serve the same purpose. It is just older versus newer version. Everything we discussed in the ReplicationController still applies to the ReplicaSet. However, there is one difference between them, and that is selectors. ReplicaSet supports the set-based selectors, and whereas the ReplicationController supports the equality-based selectors. So before we go deep into this topic, let's take a step back to understand what are labels and selectors. And this will get everyone on the same page, including those who are not aware of it. As we know, pods are basic scheduling unit in Kubernetes, just like VM in the VMware world. And these pods provide a runtime environment for applications that we deploy. So when we deploy the applications, to have a better high availability and load balancing between the applications, we tend to deploy multiple instances of the applications for that. So there will be one pod per application instance. And if you scale your application instances to 10, there will be 10 pods. So how are these pods are managed at such a large scale? This is usually done by controllers and services such as ReplicationController, ReplicaSet, services, DaemonSets, and so on. Here, the main question is, how do these controllers and services are aware of pods that it needs to manage? Answer is labels and selectors. Labels are key value pairs that are generally attached to pods. It is kind of a tag that will be given to one or set of related pods together. And it will help us managing and displaying related pods together as a set instead of individual. And if you take this pod spec as an example, we have a pod named Nginx pod, and it has 3 labels as you can see. And if we take a first one, app is a key and guestbook is a value. And that's how we define the labels inside the pod. And these are the tags that was given to the Nginx pod that we defined here. So this pod spec that you're seeing here will deploy 5 Nginx pod instances inside our Kubernetes cluster. All these 5 pod instances has the same labels. On the other side, we have selectors. Controllers and services manage these 5 pods using the selectors. So what goes inside these selectors? Any guess? Pod labels. There are 2 different ways that you can define selectors. One is the old way that is used in the equality based selectors, which is used in a replication controller. And other is new set based selectors, which is used in ReplicaSet. Now, let's see what they are and how do they differ. We have equality based selectors on the left side and set based selectors on the right side. First, let's take a look at the equality based selectors. There are 3 kinds of operators that we used in equality based selectors. They are equal, double equal, and not equal. And that is one of the reasons why it is called as equality based selectors. Here, first 2 operators are same, which is equal and double equal. You can use either one of them. On set based side, there are 3 operators as well. They are in, not in, and exists. Next, let's take a look at some of the examples and see how these operators are used. On this side, we have 2 examples. The first example, we are selecting all pods whose environment is production. And in the second example, we are selecting all tiers except the front end. On the other side, you can give 2 or more options. And this is a primary advantage of set-based selectors. So you are selecting the pods whose environments are in production and in the QA. In the following example, you are selecting all pods whose tiers are not in front end or back end. Here, you are selecting the pods from set of options, and that's why it's called as set-based selectors. So now, how are these selectors are used along with kubectl command? This way. In these examples, we are selecting and displaying all pods whose environment is production. As you can see, we are using the equal operator on this side and in operator on the other side. So, how are these defined in manifest or spec file? Like this. On this side, it is very simple. We are defining the keyword selector. Underneath that, we can copy the exact content of pod label as it is. On other side, we have a slight different approach. And we have a keyword called match expression under the selector. After that, we use key, operator, and values. If we take the first line item in the example, we are selecting all pods whose environment is prod and QA. And the other one, we are selecting all pods whose pods are not front end or the back ends. So these are the 2 different types of selectors. If you look at this at a very high level, you will get like 2 points. And that is, equality based selectors are easy to use and understand, but less powerful than set based selectors. Whereas set based selectors are a bit complex, but more powerful than equality based selectors. So which one to use? It depends on your requirement. But if you're just starting to learn about Kubernetes, practice with equality based selectors. And once you're comfortable with it, then you can start using these set based selectors as and when needed. In our demo, we will deploy an application with ReplicaSet using both examples. Before we head into the demo, there is something to clarify. In my initial days with Kubernetes, this thing confused me quite a lot. I used to see a spec file with two different types of selectors, one with matched labels and other without matched labels. This has really confused me a lot. Not sure where to use which one. Finally, after spending an hour or two on Google, I found an answer. And that is, we use selectors without matched labels on older resources such as ReplicationController and services. And we use selectors with matched labels on newer resources such as ReplicaSets, deployments, jobs, and DaemonSets. And now it's time to move on to the review demo section. In next few slides, we will review the demo we are able to perform on live Kubernetes cluster in advance. First, we will see what goes inside a ReplicaSet manifest file. Then, we will deploy the application using ReplicaSet. After that, we will deploy the ReplicaSet to make sure it is created as per our expectations. Then, we will start testing the couple of scenarios to make sure it is working as per our expectations. In first scenario, we will test the pod rescheduling when node fails. In this case, we will make sure the ReplicaSet will create new pods on healthy node inside the Kubernetes cluster. Next, we will assume there is a surge in traffic. Then, we will scale up the application instances running inside the cluster. Finally, we will scale down the application instances, assuming the traffic has returned to the normal. And now, let's start with writing the manifest file for ReplicaSet. Config file of ReplicaSet is almost similar to the ReplicationController, but with a very small minor differences. And let's write down the definition of a ReplicaSet. Like any other Kubernetes object config file, ReplicaSet contains 4 top sections. They are API version, kind, metadata, and spec. Let's go by one. First, API version. API version of a ReplicaSet is apps v1. Then kind. Kind of the object that we are creating here is ReplicaSet. So we have it here. Then follows the metadata. Two things that goes under this primarily are, one is name of the object, other is label. Here, name of the ReplicaSet is nginx rs. You can define the labels for this ReplicaSet if needed here, but for now, we'll skip it. Finally, we have a spec section. Can you guess what goes here in the spec section? If you remember the purpose of ReplicaSet, you will get an answer. Answer is, it creates multiple replicas of pod instances for high availability and load balances purposes. So, we are talking about the replicas and pods here. In our example, let's have 3 replicas of pod. Next, we need to define the pod template. So, the pod configuration comes under the template section. The question here is, how do that ReplicaSet will get to know about the nginx pods? Any guess? It is with the help of labels and selectors. We have already defined label for the pod, which is app nginx app, and the tier as frontend. Next, we need to define the selector. And this is where all the biggest difference between ReplicaSet and ReplicationController comes into the picture. As we discussed in depth previously, there are 2 ways to define this selector. One with matched labels and other with match expressions. We use matched labels when there is key and only one value. Here, we just have only one value, which is nginx app. In case if there are a set of values to select from, then we use match expressions. The way we define the match expressions is by key, operator, and value. Here, key will be always one string value, which in this case is tier. Operator can be in or not in. And finally, we have a value which in this case as frontend. You can have more values by using comma after frontend. But in this example, we have just one value which is frontend. So, we can use match labels instead of match expressions, which I personally feel a bit easy for this case. So, I showed you this to explain this concept. To summarize this, we have an API version, kind, metadata, and spec. Under spec, we define the number of replicas, pod configuration, and selector. The major difference between ReplicaSet and the ReplicationController comes in the selectors section as we discussed. Now let's go ahead and create this replica set. We use kubectl create-f command followed by the object file name, which is nginx rs.yaml file. Once you run that command, you should see the nginx rs replica set is created. Then we use the kubectl get command followed by pods to display the pods it has created. As you can see, there are 3 nginx pods which are created by nginx rs replica set, and its status shows that all 3 pods are running successfully, and which is what we are expecting. Let's assume that there are 100 other pods which are in same running status. Now we need to just want to display the pods which has the label of frontend. So how can you just display that? Answer is, all we need to do is filter the pods whose labels are tagged with frontend. We can do that by adding a label at the end of kubectl get command, just like this. Now, to describe the complete details about this nginx rs replica set, we use the describe command, and we'll see that in next slide. Before we get into the describe command, let's get the wide output of nginx rs replica set. There you see at the end where the both selectors are displayed. Next, let us display the complete details about a specific replica set. Here, we are displaying the nginx rs replica set. As you can see, labels and selectors of the pod, then the status of the pod where all 3 are running and 0 failed. Next comes the pod template, which has a list of containers this pod has, and as we see, there is only one nginx container running. Finally, you can see the list of the events where it shows all 3 pods are created. And this is one of the very important command when it comes to the troubleshooting. So far we have created the replica set, then displayed and verified to make sure it is working. Now let's test some of the use cases of replica set, which includes how these pods are rescheduled when the underlying node dies. Second, how to scale up when there is an increase in load and scale down when there is no load. First, let's look at how the rescheduling of the pods happens when the underlying node dies. We have 2 worker nodes in our cluster. They are running on node 1 and node 2. So let's test to see what happens if the pod on node 2 dies, and it manually went and shut down the node 2. Now, to make sure the node 2 is down from the command line, we will execute the kubectl get command followed by node. As you can see, node 2 is now in not ready status. At this stage, let's give it a few minutes to the master node. After some time, let's display the pods with a wide output running this command. As you see, the status of the pod on node 2 changed to the unknown, and it recreated the pod on node 1. After some time, pod with unknown status will just go off automatically. So this is what happens when the underlying node dies. Next use case that we are going to test is scaling up the replicas. Here in this use case, we will scale up the replica count. Let's assume you notice there is a sudden increase in traffic from end users accessing your web servers. Currently, there are 3 instances which are getting burned down very fastly. We came to a conclusion, and now it's time to increase the application instances based on the load. So to scale up the application instances from current 3 to 5, we use the kubectl scale command with replica option to 5. Once the command is executed, now let's display the replica set to check how many instances are running. As you can see, there are 5 replicas are currently running and in ready status, and it matches to our desired count, and which is 5. Let's execute the kubectl get pods to display the number of pods currently running under the nginx rs replica set. As you see, there is an increase in pods from 3 to 5, and there are 2 new pods created, one running on node 1 and other is running on node 2. And this is how we scale up the replica set. And now let's go ahead and scale down the application instances. Once the load and traffic from outside world is down to normal, then you can bring down the replica count. You can use the same exact process. All the difference here is replica count to 3. To verify, we use kubectl get replica set command to display. Here, RS is a short form of replica set. As you can see, desired and current are same, which is 3. Now, to see on which nodes these pods are currently running, we use kubectl get pods with wide option. There are 2 pods running on node 1 and 1 is running on node 2. Finally, it's time to clean up the things here. So to delete the replica set, we use kubectl delete command with -f option followed by config file. And this will delete all the objects which are created as part of this config file, which includes pod and replica set. Please note, if you delete a replica set, and it will delete all the pods which comes under its control. Now, to make sure, we'll display the pods with label nginx app. As you see, there are none. So far we have discussed about what is ReplicaSet, how to create and tested some of the use cases of it. So before we move on to the next video, let's review some of the important things that we discussed in this video so far. So coming to the summary, in first section, we discussed the concept around ReplicaSet, where we discussed ReplicaSet ensures that a specified number of pods are running at any point in time, always. And ReplicaSet is the next generation of ReplicationController. The primary difference between them is ReplicaSet supports both equality-based selector and a set-based selector, and whereas ReplicationController supports only equality-based selectors. Next, we also discussed about the difference between equality-based and set-based selectors. And that's about the part 1. Now coming to the part 2, where we reviewed the demo we are about to perform live on Kubernetes cluster in advance. In that review demo, we saw what goes inside a ReplicaSet manifest file. Majorly, replicas and selectors are 2 most important fields which makes this special. Then, we deployed the application using ReplicaSet. And once the application is deployed, we displayed and validated the objects it has created. Then, we tested some of the use cases of ReplicaSet by automatic rescheduling of pods when underlying node fails or dies for any unknown reason, then scaling up and scaling down the application instances. And finally, we cleaned up what we have created in this demo. And now, it's time to move on to the next video in this Kubernetes series, and which is actual demo of ReplicaSet. In the demo, we'll perform the exact steps that we just discussed in the review demo section. And finally, thank you so much for watching this, and I hope to see you in the next video. Imagine that you have deployed app inside Kubernetes cluster about a year ago. Now, you are able to upgrade that app. For example, V1 to V2. Now, let me ask you a couple of questions. Can you upgrade your app seamlessly with zero downtime? For example, from V1 to V2? Can you upgrade your app instances sequentially one after the other? Can you pause your upgrade which is in progress and resume after some testing? If something goes wrong with your upgrade, will you be able to roll back to previous state? These are some of the important questions that you need to think before you upgrade any app from current version to any new version, especially if you are doing it in production environment. If you do not have answers to all these questions, then you will find those answers in this video. Hello and welcome to deployment. So in next few minutes, I'll try my best to get you up to speed on what is deployment and what are its features, what are the different types of deployments, and how to deploy and manage your app instances inside your Kubernetes cluster using deployment. But before you watch this video, it is good to have a basic understanding of what is ReplicaSet, pods, and Kubernetes. So, without any further delay, let's take a look at the things you'll be learning as part of this video. This presentation is divided into 2 sections. In first section, we'll discuss the concepts around deployments. First, we'll discuss what is deployment, how it is related to ReplicaSet and pods. Then, we'll discuss about the features of deployment. After that, we'll discuss about the different types of deployments. So that's about section 1. And coming to the section 2, we will review the demo we are about to perform live on Kubernetes cluster in advance. The purpose of review demo is to help you better understand when you watch actually doing it live. So in this review demo, I'll show you what goes inside the deployment manifest file. Once manifest file is ready, then we'll deploy application using deployment. Then we'll execute a couple of commands to make sure it is deployed and objects it has created successfully. After that, we'll test various use cases of deployment, such as update, rollback, scale up, and scale down. Finally, we'll clean up what we have created. In case if you are looking for actual demo on performing above steps on live Kubernetes cluster, then you can refer to the link provided in the description below. And now let's get started with what is deployment and what it does. So, what is deployment? Deployment is a controller just like any other controllers such as ReplicationController and ReplicaSet. Then, what's so special about deployment? So if you take a look at a very high level, deployment is all about updates and rollbacks. So a deployment controller provides declarative updates for pods and replica sets. These updates are not only just changing the older version number inside the spec file to newer version. It also includes increasing or decreasing number of pod replicas. To explain this concept better, we need to go through the short history lesson right now. As most of us are aware, generally we deploy microservices applications through containers. In Kubernetes, related containers are grouped together inside a pod, just like this. So technically, inside a pod, you can have more than one or more containers. So to have a high availability and load balancing, we prefer to have more than one instance of application running always. In our case, there are 5 identical pods are running, which means 5 identical application instances are running. So let's imagine that we are deploying an application with 5 instances of it. We do that by ReplicaSet. But what ReplicaSet does not provide features such as upgrades and rollbacks. For that, we need deployment. So overall, we are looking at 3 different objects: pods, ReplicaSet, and deployments. So now the question is, do we need to create 3 different manifest files for each one of these? Answer is no. We can manage all 3 different objects using one single deployment manifest file. Deployment manifest file contains the pod definition, number of pod replicas that we need, and also you can mention about your preferred upgrade strategy you want. Going forward, we don't deal with individual pod or replica set spec file. We manage all that using one deployment manifest file. So that's about the deployment. Now let's take a look at other features of deployment. First, multiple replicas. With the help of deployments, you can create multiple replicas of pods for high availability and load balancing. So when you create deployment, by default, Kubernetes will automatically create replica set in the background for you. In case if you don't mention replicas in the deployment manifest file, deployment will create replica set with a count of 1. So advantage of having replica set with even 1 is it will make sure and safeguard this one pod is running always. So if something happens to this pod and dies, it will try to recreate it again on same node or a different healthy node. So you can manage the number of replicas using the deployment. Second, upgrade. We have been talking quite a lot about upgrades since the beginning of this video, because upgrade is one of the core features of deployment. There are different types of upgrade strategies available to make use in deployment. We'll discuss about that in next slide. Third, rollbacks. If something goes wrong with current upgrade, then deployment controller will allow you to roll back to previous stable version. Fourth, scale up and scale down. So once you deployed your application, you can scale up and scale down the application instances based on the load. For this, all you need to just do the update replica field in deployment spec file accordingly. Finally, pause and resume. You can pause the deployment process in progress as and when needed. You can use this feature to test and validate new version of the application. So these are the primary features of deployments. And now let's take a look at different types of deployments. There are multiple types of upgrade or deployment strategies you can use. For the sake of discussion, let's assume we are upgrading from version A to version B. So, first deployment strategy is recreate. The recreate strategy is a dummy deployment which consists of shutting down version A, and after making sure version A is turned off, then you start deploying version B. So during this switching from version A to version B, there will be a downtime of the service. This is very easy to set up, but there is a downtime while there is switching from version A to version B. Next, rolling update. Rolling update deployment will slowly roll out a version of an app by replacing instances one after the other until all the instances are successfully rolled out. Let's assume there are about 10 instances of version A, which is running behind the load balancer. Then, update strategy starts with one instance of version B is deployed. When version B is ready to accept traffic, the instance is added to the pool. Then, one instance of version A is removed from the pool and shut down. Rolling update is a default update strategy in Kubernetes. It is easy to use, but this rolling update can take some time. Next, canary deployment. Canary deployment consists of gradually shifting production traffic from version A to version B. Let's imagine that there are about 10 instances of app version A running inside your cluster. You use the canary deployment when you do not want to upgrade all at once. Let's say you first upgrade your 2 instances of version A to version B, then do some testing. If the test results are good, then you upgrade remaining 8 instances to version B. So once the version B is ready, then you completely shut down version A. So basically this is ideal deployment method for someone who want to test new version before it is deployed 100%. So that's about the canary deployment. And finally, blue-green upgrade strategy. Using this deployment method, version B, which is green, is deployed alongside the version A, which is blue, with exactly same amount of instances. So after testing new version meets all the requirements, the traffic is switched from version A to version B at the load balancer level. Advantage of this is instant rollout and rollback. So that's about the blue-green deployment upgrade strategy. So that's about the different types of deployments or upgrade strategies. As I mentioned earlier, rolling update is a default update strategy in Kubernetes. And now it's time to review the demo. In next few slides, we'll review the demo we are able to perform on live Kubernetes cluster. First, we will see what goes inside the deployment manifest file. Then, we'll deploy the app using deployment. After that, we'll display the deployment to make sure it is created as per our expectations. Then, we'll start testing with a couple of scenarios to make sure it is working correctly. In first scenario, we'll upgrade the app from lower end version to higher version. Then, we'll see how we can roll back if something goes wrong. And finally, we'll scale up and scale down the app instances when there is surge in traffic and when it comes to normal. And now, let's start with writing a manifest file for deployment. Like any other Kubernetes object config file, deployment contains top 4 sections. They are API version, kind, metadata, and spec. Let's look at this one by one. First, API version. API version of deployment is apps v1. Then kind. Kind of the object that we are creating here is deployment. So we have it here. Then it follows the metadata. Two things that goes primarily under this are, one is name of the object and other is label. Here name of the deployment is nginx deploy. Next, label. Label that is given to this deployment is nginx app. This label is optional, but it comes handy when it's managing this deployment. And finally, we have spec section. Can you guess what goes here in this spec file? Mainly three things. First, number of pod replicas that we need. Here in this case, we are creating 3 pod replicas and it will take default value as 1 in case if you don't mention anything. Next, pod template. In this example, we are having a pod with one container with nginx image and label for this pod is nginx app. Finally, selectors. These selectors are used for identifying and managing the pods. Here we copy exact pod labels under selectors. So that is it. If you observe this closely, this deployment manifest file looks exactly as a ReplicaSet with only one minor difference, which is kind. Besides that, everything looks exactly same. Now let's go ahead and deploy this. So to create the deployment, we use kubectl create command followed by -f option with manifest file name. From the output, it is confirmed that deployment has created successfully. So now to display the deployment, we use kubectl get deploy command. If there are multiple deployments, you can filter the target deployment using labels as shown here. You see all 3 pod replicas are running and available. From the output you can see all 3 pod replicas are running successfully and available. If you run same command without that label, then it will display all the deployments on Kubernetes cluster. Next, when you create deployment, it will automatically create the replica set. So let's go ahead and display the replica set which this deployment has created. You can do that by adding label filter at the end of the kubectl get rs command. That is a replica set which was created in the backend automatically when we created this deployment. Next, let us display the pods which are part of this deployment. We can do that by using kubectl get pods with a label as app equal to nginx app. As you can see, there are 3 pod replicas which are in running status. So far, everything looks green and successful. And now, let's see how to print the complete details of deployment we just created in next slide. For detailed output of nginx deployment, we use kubectl describe deploy command followed by deployment name. I have highlighted all the important fields with green, and most of them are self-explanatory. One thing I want to focus here is strategy type, and that is the upgrade strategy. If you remember, we discussed about the 4 different upgrade strategies. And as we discussed earlier, rolling update is the default upgrade strategy. Also, you can see the list of events at the end. And now, it's time to test some use cases of deployment. And let's see what is the first use case that we are about to test. Update. Currently, each pod is running with nginx web server. Its current version is 1.7.9. Now, in next slide, we'll upgrade it to nginx 1.9.1. And let's see how it is done. So to upgrade, there are 2 ways to do it. One using kubectl set command and other using kubectl edit command. I'll show you the 2 ways. But first let's take a look at kubectl set command. So by using kubectl set image deploy command followed by deployment name, which is nginx deployment, and finally we will set the nginx container to new version which we want to upgrade. In this case, it is nginx 1.9.1. As you can see from the output, deployment image is successfully updated. Second option is to upgrade by editing deployment configuration is through kubectl edit deploy command followed by the deployment name. Once you run this command, configuration of this deployment will open in VI editor. Then you can change the replica count, image version, and other configuration and close it. As soon as you close it, configuration will get automatically updated. You can check the status of deployment using kubectl rollout status followed by deployment name. As you can see, deployment is successfully rolled out. Finally, to display the deployment, we can use kubectl get deploy command. This will list all the deployments on the master node. In case if you want to display only specific deployment, then you need to provide the deployment name at the end of this command. So that's how you update the deployment. So let me ask you something here. What if you accidentally gave Nginx version as Nginx 1.91 instead of 1.9.1 in the above command? It will get stuck. Then you need to roll back. Now let's see how you can roll back the deployment in next slide. In next test case, we are able to upgrade Nginx version from 1.7.9 to 1.9.1. Accidentally, we missed dot after 9. In that situation, we need to roll back the deployment to previous stable version. And let's see how that is done in next slide. Let's upgrade Nginx image to 1.9.1 using kubectl set image command. As you can see in the above command, we accidentally gave version as 1.91 instead of 1.9.1. But luckily, we are giving record option. So the Kubernetes will record this command in its history. Once you run this command, output shows that image has been updated. This output is very misleading because when you check the status of deployment using kubectl rollout status, you see it is waiting for something. So after a while you see that same message. Now you start thinking about something didn't work as it should be. So to find out what commands you have executed prior, you can use kubectl rollout history command, which will print the commands you have executed as part of this upgrade. From this output, you can notice error which is missing dot after 9 in the Nginx version. So to correct this, we need to undo this deployment by running kubectl rollout undo deployment command followed by Nginx deployment. After that, you can check the rollout status. As you see, Nginx deployment has successfully rolled out. And now, it's back to its original status. So this is how you roll back to previous stable version if something goes wrong. Next, we'll see how to scale up and scale down the pod instances. Currently, there are 3 pods running in the Kubernetes cluster. And let's consider 2 scenarios. One scenario is where we scale up and other scenario is where we scale down. First, let's look at the first scenario, and that is scale up. Here in this use case, we'll scale up the app instances. Let's assume you notice there is a sudden increase in traffic from end users accessing your website. Currently, there are 3 app instances running, and it is getting burned down very fastly. And now it's time to scale up the app instances by adding another 2 new app instances to the cluster. So to scale up app instances from 3 to 5, we use kubectl scale deployment command with replica count to 5. From the current output, it is confirmed that it is successfully scaled to 5. So once the command is executed successfully, now let's display the deployment to check how many instances are running. As you can see, there are 5 replicas currently running, which is equal to desired count, which is 5. Now, let's execute the kubectl get pods to display the number of pods currently it's running. As you can see, there is an increasing number of pods from 3 to 5. There are 2 new pods are created. So this is how we scale up using kubectl scale deployment command. Now, let's see how to scale down the app instances. Next slide. Once the load and the traffic from outside world is back to normal, you can bring down the replica count. You can use exact same process. The only difference here is we'll decrease the replica count from 5 to 1. Once that is done, you can verify the kubectl get deploy command to display it. As you can see, the desired and the current are same, which is 1. Now, let's deploy all the pods which are part of Nginx deployment. As from the output, it is confirmed that there is only one pod is running. So that's how we scale down the app. And now it's time to clean up what we have created so far in this video. And we'll do that in next slide. So to delete the deployment, we use kubectl delete command with -f option followed by manifest file we used while creating this. So this will delete all the objects which are created as part of this manifest file, which includes pods, ReplicaSet and deployments. So to make sure, you can run kubectl get deploy command. Also, to make sure there are no pods which are part of this deployment, you need to run kubectl get pods with label nginx app. As you can see, there is none. So everything is clean now. So before I end this video, let's review some of the important points that we discussed in last few minutes. So coming to the summary, in first section, we discussed the concept around deployments. First, we discussed that deployment is all about updates and rollbacks. So using deployments, you can upgrade the image version and increase the number of replicas. So you can manage pod replicas directly using deployment manifest file. It contains a definition for pod template and also you can have the replica count. Next, we discussed about the features of deployment such as update, rollbacks, pause and resume, scale up and scale down. After that, we discussed about different types of deployments such as recreate, rolling update, canary and blue-green deployments. And section 2, we reviewed the demo we are about to do in live in Kubernetes cluster. I showed you how to write the deployment manifest file. Then we created the deployment. After that, we executed a couple of commands to make sure it is deployed and objects as created successfully. Then we tested various use cases of deployment, such as update, rollback, scale up and scale down. Finally, we cleaned up what we have created. And now moving on to the next video, and that is actual demo of deployments. In that demo, we'll perform the exact steps which we just discussed in review demo section. And finally, thank you so much for watching this and I hope to see you in the next video.